Hey, I'm here and you're here, so that's enough to start the stream, right? I agree. Let me go on to my Discord and say I'm streaming now. So, stream plan. There's no plan. So, catching up, doing day 8 and 9 when it unlocks. Put the link. Okay. How is the AV sync? Testing 1, 2, 3, 4. Looks good. Got the transcoder, that's also good. These are all good omens. Now, what are we doing? Admin of code, day 8. I'm behind by a day. Wasn't able to stream yesterday. Got up to day 7. One thing I wasn't able to see at the end of day 7 was private stats because it was down. Let's go look at them now. Personal stats, I should say. Yeah, so I suffered quite a bit. I got stuck for 2 hours. I guess one saving grace is once I solved part 1, I got part 2 in like 12 minutes. So that's not bad. But yeah, rank suffered quite a bit. Rank for day 6 and day 3 we don't know because I didn't start when it unlocked. Did really good on day 5. Day 1, 2, and 4. That's sort of my baseline, is between rank 2,000 and 3,000. Okay. Just making sure everything is working. Everything working? Audio working? Video working? Camera working? Sitting up straight, not slouching? Have something to drink? Yes. Oh, I need to resize some of my windows here. Let me fix that. All right. Okay, so I'm doing Admin of Code 2021, and we're on day 8. Day 9 is actually going to unlock in a little bit over 2 hours, so I gave myself about 2 hours to do part 8. Hopefully I won't get stuck like I did in part 7, in which case I might have to stop in the middle of doing day 8 to do day 9. Also, probably fortunately, the days this year don't really depend on previous days, so that's good. So I don't know if anyone's here, but I'll just describe it for people who might be watching the VOD. What is Admin of Code? It is 2 programming puzzles per day from December 1st to 25th. They're Christmas themed. They're pretty corny, but they challenge you to solve a problem as fast as you can in a new language or in a new way. You know, anything you want to challenge yourself with. I think the creator of Admin of Code says that as long as you're learning something and you're having fun, then it's all good. So the premise of this year is that on day 1, we're on the ocean, and oops, dropped the keys to Santa's sleigh in the ocean. So now we have to get in our submarine, go all the way down to the ocean bottom, see where that set of keys went. And the last one, day 7, was about we were going to escape a giant squid and going into some subterranean caverns. That's probably what where we're gonna start here. 7 segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth. Oh yeah, it was a giant whale, not a squid. The squid we already found earlier, and we played bingo with the squid. Don't ask. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of 7 segments named A through G. A, B, C, D, E, F, G. So to render a 1, only segments C and F would be turned on. The rest would be off. To render 7, only segments A and C and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. Submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All the digits within a display use the same connections, though. Wait a minute. What's a display then? I think I missed that. Hey there, Crumpet. How are you doing today? Oh, okay. So we have 4-digit 7-segment displays, but how many displays we have, they haven't really said yet. Didn't Will have been an easy day? Good. Today's been a okay day for me. It's been an easy day, of course. Yes. I'm glad. Okay, so this is where I got confused initially. All of the digits within a display. So a display is 4 digits. A digit is 7 segments. Got it. So you might know that only one... where did I see the word 1? There's no word 1. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so that it must mean that segments C and F are meant to be on. With just that information, you can't tell which wire B or G goes to which segment C or F. For that, you'll need to collect more information. For each display, you watch the changing signals for a while. Make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see in a single entry in your notes. All of that. This entry is wrapped here to 2 lines, but it's really 1 line. So that's our example then. Should have set this up before, didn't, so we're going to do it now. Day 7 will copy to day 8. In lib, we'll make a mod for day 8. And we're going to copy this export for day 8. And in main, we'll have our main runner handle day 8. Like so. If I could type. And sure, we'll just add benchmark for it too, because we're going to want to make it fast, right? Make sure it builds, so I would do like 2021 cargo run 8-1. Okay, that's really solving day 7. So I made a couple mistakes before, I'll fix them now. Like when I copy day 7 to 8, it should be 8.txt up here. And we'll go ahead and delete all of the code that was here. Hey there, poison process. Yes, I know, I'm coding. I'm coding Advent of Code. I got permission to do Advent of Code, so that's what I'm doing. Again, Advent of Code puzzles solved by doing some programming. 2 puzzles per day from December 1st to 25th. And technically, I can go back and do all the previous years. So even if we run out of puzzles for this year, I can go back and do the other ones too. Okay, so let's make a 8.txt that's empty for now, just to get this one to compile. And right, I did all that because I want to take their example and plug it in as a unit test here. And I'll remove this break. Okay. Hey there, Jesse Skinner. How are you doing? No, it's job permission. I got a new job in April, and it took me a while to get the go-ahead to do coding, to do live coding again, and also to do YouTube videos on introductions to coding. So they had policies in place where you can't do it unless you get approval from business relations, and so it took a while. So I can do it now again. Which is cool. So each entry consists of 10 unique signal patterns, a pipe delimiter, and finally, oh, so I need to keep that pipe there. Okay, we'll keep the pipe. In fact, yeah, it's going to wrap it for me, right? So do that. Yeah, well, it pays the bills, right? So I'm okay with the compromise, and I'm okay with the temporary ban. I guess I can think of it as that's all in the past. So we're all good now, right? Okay, so the pipe, hold on. 4-digit output value. Why do they only have 1 pipe though? Oh, 4-digit output value. Got it. So apparently, like, these we can all use to figure out the signal mappings. And once we figured them out, then we use these to get our output, right? Thanks, Jesse. So within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current. Yes, we know that. Because 7 is the only digit that uses 3 segments. DAB, in the example, means that to render 7. D, A, and B are on. Because 4 is the only digit that uses 4. E, A, F, B means that to render 4 signals E, A, F, and B are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. Yes, that's true. For now, focus on the easy digits. Consider this larger example. Okay, so we have 2 tests? Or this is not the real test, this is the real test? I'm going to take it that this is the real test. They just gave us a shorter test just to be nice, I guess. Let me line this up, guess I can. Because the digits 1, 4, 7, 8 each use a unique digit number of segments, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, the part after the pipe, there are 26 instances of digits that use a unique number of segments highlighted above. In the output values, how many times do digits 1, 4, 7, and 8 appear? Okay, so I guess they're telling us to break the problem down into 2 steps, and part 1 is the first step. So 26 is the answer for this example. Right? They're asking the same as what they're giving as an example there? Yes. Okay, so it's the ones that are highlighted. The easy digits. So the one with all 7 segments is 8. But that doesn't really tell us anything, right? Does the order of these matter? If the order doesn't matter, then the 8... okay, well, that's not what it's asking. It's really asking how many times do we have one that's 8 long, one that's 4 long, one that's 2 long, and one that's 3 long. So that's, because that's an 8. The 4 things lit is which one? A 4. The one with 2 lit is a 1. The one with 3 lit is a 7. So yeah, 1, 4, 7, and 8. Got it. Okay, so let's just solve this part of it. I'm already thinking ahead. I know what part 2 is going to be. Part 2 is going to be decoding what's after the pipe for some, figure out exactly what the digits are. I already know it. So we're just going to get the input and toss the pipes. The pipe is getting in our way, actually, to start with, right? Input dot line. We don't even need dot lines. Input dot split on. Actually, just split white space. And then map group. I need to actually, if the pipe is present, where will it be? It'll be on its own. So I think we'll just filter out pipes. Filter. Group is not equal to pipe. Right, and then what's on the remainder, we'll just count the ones that have the length of 2, 3, 4, or 8. So again, the filter. Group.len is equal to 2 or 3 or 4 or 8, right? 2, 3, 4, 8. And then count it, and then as a string. I need to dereference that. What is it not like about as string? Oh, it's toString. Yeah, there we go. All right, let's see if I got it. We counted 49, not 26. So what did I do wrong there? Oh, why did it highlight these but not this one? Let's see. Only digits in the output values, the part after the pipe. Oh, okay. I have to, I did it wrong then. I misinterpreted that. So actually I need to look for where the pipe is. So that's, yeah, so we need to do split into lines first. Then map a line to a line dot strip prefix. No, just do split once on pipe. Unwrap and then take the second one. And then flat map that. Then split on white space. We don't have to filter. Flat map, did I do it wrong? As lines is not an... Wait, what? Hey there, Maximum Homer Drive. How are you tonight? Today, this morning, this afternoon, wherever time zone you're in. Oh, shoot, that needs to be, let me think about this. This needs to be a map group. Group. I can't type tonight. Doing all right? Your brain is melted already watching me do this? Things are going all right. Is it melting because you're not familiar with Rust? Because I can understand that. If I didn't know Rust, looking at this, I'd be like, I sort of understand parts of it, like getting the length, but blah, what is this? And it's even arguably harder to understand with inlay hints on. With them off, it might be less clutter, and so you might make a little bit more sense. I keep the inlay hints on because they're telling people who know a little bit about Rust that like input is a &str, which is a read-only view into a string. So we get a pointer and a length. We can't change the length, and because it's just an ampersand, that tells me within the syntax that we can't change the characters either. So knowing a little bit of Rust, the inlay hints can help people to see what I'm doing on each line. And this is what I like to call it a function chain. So we're taking something and running it through a function, and then that output, we're running it through another function, and that output, we're running through another function, kind of like an assembly line. So we're taking our input string, cutting it into lines, and then the idea for this, but I have it wrong somewhere, but the idea is for each line, split the line on the pipe symbol, and then unwrap basically means if it's an error, just panic. Otherwise, give me the success result. Right? Only give me a result if it's successful. Otherwise, error out. And the .1 means the one on the right of the split. So give me this is basically saying give me everything on the right of the pipe symbol. And then here I was saying for every group in that line. Oh, this is where I got it wrong. This should be line again. And it's not flat. Oh, I see where I went wrong. This should be flat map. For every line, take the line and split it on ASCII whitespace, and that gives me a list of groups of digits in that line, and then flat means to flatten that whole thing into one iteration. So basically collapse the lines back together, right? Because we don't, at that point we don't care. Then filter basically says for each one of those groups of characters, only let them through the next step if they have a length of 2, 3, 4, or 8, because that was the condition of this thing right here, where they said only let the group of 8, the group of 4, 3, and 2 through, right? Then count that number and convert it to a string and give me the answer. You took C++ course 15 years ago. That was the last time any coding happened. Yeah, then this would be doubly hard because it's hard to go from C++ to Rust, personal experience. And it's hard to understand something if you haven't done it in like more than a few years in the past, for me. Depends on the person, how good your memory is and all that. But yeah. Okay, I have an unwrap of a none value. So I think it is because I didn't combine these lines together. I need to do that. Actually, I should probably check my actual puzzle input to make sure, but it's probably like going to be like this, where they're all on the same line. Otherwise, I have to do something more clever. Let's see what our puzzle input really is. Yeah, see, they're like I hoped. They're all, each line is a different thing with one pipe in it. So let me go ahead and paste that in there, right? I should also be prepared to handle like that last line, which is empty. Well, let's cross that bridge when we get there. Let me just see if this works. Still failing. Counting 19 instead of 26. Why am I only counting 19? How many actually are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Yeah, there are. I counted 25, but I probably skipped one. Why does it? 2, 3, 4, and 8, right? 2, 3, 4, and oh no, it's 7, not 8. Okay, that's my bug. 7. Run that again. Okay, now it's passing. So that gives me confidence that if I run it with the real input, I'll actually get the correct result. Okay, so I didn't have to account for that last empty line. Hopefully I got the right answer. Yes, we got the right answer. You remember essentially none, so at least C++ isn't working against you. That's true. But anything you might remember might confuse you. That was my experience. But I hope that this makes sense. I can go over this again. So our input, in Rust, there are many different types for a string. You know what a string is, hopefully. It's one of these things. It's just a sequence of characters, numbers, letters, dots, etc. The capital string is the type of string when you own the value, so that when you're done with it, it'll get deallocated. You can change its length, you can change the characters in it, all that stuff. You have total control over it. This form of string, for some reason they decided to abbreviate it rather than doing that, but whatever. This form of string is one where it's like a view into a string. You don't own the string, someone else does. You get to just peek into it. So you know where, like how many characters you're allowed to see, and it doesn't have to be a view starting at the beginning. It could be a view into the middle or the end. And then this special symbol in Rust means that we're borrowing it. So usually with this string view, or what they call a slice, in order to actually use it practically, you have to be actually borrowing that view, because you can't own a view. Because I think there's technical reasons, like the view doesn't actually have a size. So yeah, anyway, I won't get into that. Just remember, just think about this as like a string you can change, and this is a string that you're borrowing from someone else, so you can only peek into it. So we're peeking into our input, whatever it is. Lines is a function that will take a string and find all the line endings and cut them up and give you an iteration, or in other words, like a sequence. So every time you ask the sequence for the next thing, it'll give you the next line in this case. And then from each point on, you see that they're all like impl iterator, because I don't know why it says lines there. lines is an iterator though, because of this. Anyway, so beginning with the output of lines, we're dealing with iterators. Which you think of iterators as like an assembly line. We're going to take everything that's in that sequence and apply some function to it. So map is the simplest, where we apply this function that we give it in parentheses. And this is like a closure or lambda expression. It's basically an anonymous function that it doesn't have a name, and we specify its arguments in these pipe symbols, so it's a line. So one line, and what do we do with it? We split it once at the pipe symbol, and because split once can either succeed or fail, and we know it should always succeed, unwrap says, if you succeed, just give me the return value, but if it didn't succeed, crash. And then split once, if it succeeds, gives you two things, a thing on the left and the right, 0 and 1. So we want the one on the right. Then, having that segment of the assembly line done, we move on to the next, which is this flat map. That's like map again, only because we're taking the line and again splitting it. So like we're almost making a second dimension. Like for every line that comes down the assembly line, we're going to split that into a sequence of things separated by white space. The flat map tells them to fold those two together so that now every unit on the assembly line is one set of characters split by white space. So instead of one of these, so we went from one of those to essentially one of these to now 4 of these, right? So whereas we started with this number of lines, we're going to end up with this many groups, 4 times the number of lines we had. And then for every group of characters, we're seeing what its length is. If it's 2, 3, 4, or 7, then we're going to return true. And filter says, let everything through that we return a true for. Otherwise, if it's false, you dump it off the assembly line. And then the last part of the assembly line is just count them. So we're essentially reducing that sequence of strings into a counter value just by counting them. And then toString to change from an integer type to the string type. And I have a string type for input and output just for uniformity. So hopefully that kind of makes sense what I did. You get the general idea? Cobbled macros together in Excel poorly on occasion. Yeah, so it's kind of like that. So, yay, we got the correct answer for part 1. Let's move on to part 2. Through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above, this one. So a lot of processing the inputs to find matches and count the matches. Yeah, because the whole problem for part 1 was to take this bunch of characters, just isolate it down to what comes to the right of these pipe characters, and then find how many groups have exactly 7 characters, 4 characters, 3 characters, or 2 characters. And they kind of did it in this example by highlighting them. But that's what our program is doing. Just count them. It says, okay, 26 of them. So part 2, we're going to go a little bit further, because the original description was that our submarine has these 7 segment displays, kind of like what you have on alarm clocks. And but we don't know which wire goes to which segment, so we don't know how to fix the wiring so that it displays the numbers correctly. So I'm guessing in part 2, that's what we're doing. So to determine the remaining digits, considering this, after some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration: A, B, C, D, E, F, G. So that's probably because, yeah, A and B for the 1, A and B, and 7 would be A, B, D, right, that. But then how do we tell? Probably because the 2 has an A in it but not a B. And the 2 is how many digits? 1, 2, 3, 4, 5 segments. So here's one that has an A but no B in it. Another one that has, okay, this one has an A and a B in it. So that's probably, I should probably write this down. Unless they've written it down for me. No, they haven't. I'd like to write it down. Let's write it down here. So a 1 is 2 segments. A 2 is 5 segments. A 3 is 1, 2, 3, 4, also 5 segments. A 4 is 4 segments. A 5 is 1, 2, 3, 4, also 5 segments. A 6, 2, 3, 4, 5, 6 segments. 7 we already knew is 3 segments, and 8 is all 7 segments, and 9 is 6 segments, just like the 6. And we forgot 0. 1, 2, 3, 4, 5, 6. So then, like, the 1 stands out, and so does the 7, and so do the 4. This is why we did this in part 1, right? Because those stand out as being the only numbers that have a certain number of segments lit. The remaining fall into, looks like there are 2 groups. So we have 2, 3, 5, and we have 0, 6, 9. So how do we tell the 2, 3, and 5 apart? It's by which ones they share in common, right? So 2, 3, and 5 share everything in common except for this one, that's marked C, and then the E, and the F, right? C, E, and F. So 2 has C and E, 3 has C and F, B has B and F. Oh, so B is included. So it's these ones on the vertical plane, right? C, E, C, F, and B, F. So 2 of them have F, 2 of them have C, 1 of them has B, and 1 of them has E. All right, and then for 0, 6, and 9, so the C versus D for 0 and 6, and then the E. So 0 and 6 have E, but not 9. 0 and 9 have C, but 6 doesn't. And then 6 and 9 have a D, but 0 doesn't. All right, so I'm just going through this in my head so that I can follow along what they say. These sequence patterns will correspond to the following digits. Or are they just giving us that? C, D, F, B, E. That would be a 5, yes. G, C, D, F, A. That's a 2, yeah. And that's a 3, yes. We know DAB is a 7. Okay. Then the 4 digits of the output can be decoded as 5353. So the order is always the same, right? No, they're scrambled. Right? That's not the same as that. Okay. Following the same process for each entry in the second large example above the following, the output value for each of them can be determined as, yeah, well, we know that's 8. Okay, and anyway, adding all the output values in this large example produces, here's the answer for our test for 2. And we're using the same test input, right? So I can just kind of copy this part, but not make the same mistake I've made before, of course. I need to make that a 2. What did I do wrong? Oh, what the heck? Why didn't it? Why is it not saving? I don't know. Is it just, I think it's just too much text here. So it doesn't know to indent this. So we'll just do it manually. All right. And then just don't touch it. Actually, let's line this up. All right. But this should fail, right? Because I get it not implemented. Correct. Yesterday, one rabbit came to your home. But it goes away, comes back again and again. Did someone feed it? Maybe it's domesticated. And it thinks that you'll feed it. Okay, so let me think about this. I got some time, right? An hour and a half. How many groups is there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I'm not understanding one crucial thing about this. Like, are the orders just scrambled always? Because, so does the order in this list matter? Orders are different. But they said within each segment, they're the same, right? So which segment are these from? I guess that's what I don't understand. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. What does that mean within an entry? Each entry. What is a signal pattern for one 7-segment display? I guess I just don't understand that. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. And before I get into how I would solve this, I'm trying to understand this. What does that mean, the 10 different ways? Oh, 0 through 9. I get it. Render a digit using the current wire segment connections. But they said the wire segment connections are different for each of the 4 displays, right? Maybe that's wrong. For each display, you watch the changing signals for a while. Make a note of the 10 patterns you see, and then write down a single 4-digit output value. Oh, this is one segment, or this is one 4-digit display. Okay. This is the part that I think is tripping me up. They say the wire segment connections are mixed up separately for each 4-segment display. Did they say how many displays we have? I guess that we have as many displays as we have lines. So here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 displays, right? But in the real input, we had 200 displays. I think that's what they're trying to tell us. So if I'm right about that, then why are like the orders different? So why is that ordered differently from that? Within an entry, the same wire segment connections are used. Okay, I think I get it. We're supposed to figure out this configuration based off of what we're given. So like doing it the same way they did, like it's not DAB for us, it's EDB. And BE. So that means the E must be the, no, the D must be at the top. Is that true always? No, see for here, C, B, G, and GC, so it's B that's at the top for this second line. Okay, so I think this is part of the answer, right? We look at the difference between 1 and 7 to figure out what the top segment is. So let's just figure this out now. I guess we'll just use this as a handy little cheat sheet. There. And then 1 and 7 determine D, right? And then how do we figure out the rest? Let's do the deduction ourselves. Oh, between 0 and 8, we know which one the middle one is. 0 and 8 tells us which one F is. What else can we learn from this? 5 and 6 tells us which one E is. Or G in this case here. Between 8 and 9, we know which one also is G. Yeah, 5 and 6 or 8 and 9 tells us G. Which one do we want to figure out next? How about E? How is that one different between two? Don't know yet. Pick a different one. C in this case. Where does it actually change? I don't see it. Hey there, Jackamus. How's it going? Going pretty well here. Just having fun with trying to deduce the rules to this part 2 here. Those are the easy ones, right? Difference between 2 and 3 tells us, well, narrows it down between, I can say 2 and 3, narrow it down between G and B. Trying to finish up some work for the day? All right. Sounds good to me. Between 4 and 5, the 2 extra ones are A. Okay, so between 4 and 5, we can figure out A and G. Or I should be consistent, D and C. And for 2 and 3, it was these lower two, G and B. Hey there, Sarian. How are you doing? I'm just figuring out the logic in the 7-segment displays. Was G the right one for 5 and 6? Yes. So it's the one that 6, the one that 5 doesn't have, and the one that 9 doesn't have is G. Okay, so then I don't see A in there. Or here they call it C. Oh, this is wrong. 4 and 5 have more differences than that. Let me delete this. Well, the 2 that segment are off on is 5 and 6. Can I say like 5 and 6 tell us, in this case, A? All others have it. 5 and 6 don't. I should write down notes for this. Between 1 and 7, D. 1 doesn't have it. 7 does. 0 and 8, it's 0 doesn't have it. 8 does. Between 5 and 6, it's 5 and 9 don't have it. 6 and 8 do. 2 and 3 are 2 has G, 3 has B. So we figured out which one haven't we done a rule for? So this one tells us which segment D is for sure, because 1 and 7 we know which ones they are. Where were my notes for? Oh, right up here. So how do we tell? So we know these 4 easy ones. How do we tell 2, 3, and 5 apart? Going through a similar route that you did? Yeah, it's just trying to figure out the logic. So 2 and 3, let's separate these rules to separate. So between 2 and 3, what about 5 and 2? 5 and 2. Okay, 5 and 2 have 2 different sets. There are 3 different combinations, right? Those are the combinations. So between 2 and 5, E, G, and or EB and AG. 2 has AG, 5 has EB. Between 3 and 5. Oh, it's A and E. A and E. 3 has A, 5 has E. Okay, then we need rules. So this rule stands alone. That we know this. We can figure this one that one out easily. I'm guessing through looking at differences between the ones that have 5, we can figure out which ones are 2, 3, and 5 that way, right? I think. So the remaining groups 0, 6, and 9. Oh, yeah, here's another easy rule. So we can figure out F. We can figure out D and F easily between these are all unique, right? Oh, no, they're not. 0. We don't know which one's a 0, 6, or 9, so take that back. So let me leave that rule for later. 0, 6, and 9. Okay, 0 and 6, we can tell 0 and 6 apart because of B, A, and F. 0 and 6. Let me write these all out. 0 and 9, and then 6 and 9. Is 0 and 6 is A and F. 0 has A, 6 has F. 0 and 9. It's this segment here. So that's F and G. 0 has G, 9 has F. And then 6 and 9. It's A and G. 6 has G, 9 has A. Okay. So we can figure out which one is D. If we know which one is D, how does that help us? Using one of these other rules. I don't think D is ever used anywhere else, so that doesn't really help us with any other rule, right? In this case, it's A. Does it help us distinguish between 0, 6, and 9? No, they all have it on. Does it help us with 2, 3, and 5? No, they all have it on. So it doesn't help at all. Your experience D doesn't help? Yeah, it didn't help. Okay. But at least there are only 6 segments to figure out now. A, F, and G. And this one is A, F, G. So 0, 6, 9 lead us to distinguish between, they differ in AFG. 2, 3, and 5 are B, G, A, and E. These ones. Right? So this center one that I'm calling F, zero, 6, 9. 0 doesn't have it. Two, 3, and 5, they all have it, so it doesn't help. Ooh. Tricky, 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 tricky. Need to stay hydrated. I should probably leverage these other unique ones. 4 helps us know oh, actually, there we go. So 4 has A, B, E, F. We can identify which one is 4, and we can identify which one is, well, 8 doesn't help us, right? It has all 7 segments lit. So we're throwing that out. It doesn't help at all. 7. 7 tell us D for sure, and we can identify the other 2 are A and B. D plus A, B. So then we can narrow down to which one, to 2 that are either E or F, right? I kind of feel like I should be making a matrix out of this. Hey there, Anthony Writes Code. How are you doing? And hey there, Adesu Used. How are you doing? Counting common segments between 1 and 2, 3, 5. That's what I was doing now. So the common segments between 1 and 7 are A, B, and the common segments between 1, 7, and 4 are A, B, so that we can distinguish D, and we can distinguish which one 2 are E and F. So we know the groups. We know the group D. We know the AB group, and we know the EF group. Maybe that's another way I can write this. So we know D. We know the AB group, and we know the EF group. So 2, 3, and 5 look harder for me. Let me look at 0, 6, 9. 0, 6, 9. Okay, let me look at it a different way. That's not helping. So the ones that have, the one where we can tell A from B apart is 2, 5, 2 and 5, right? 2, 5, and 6. Oh, there we go. That was our group. No, it wasn't. So 2, 5, and 6 don't have A in them, but they do have B. This is like a brain twister. This is hard. I kind of just want to do the coding for it. I guess we'll just write down this rule that 2, 3 and 5, no, 2, 5, and 6, right? 2, 5, and 6 can tell, distinguish A from B. And how do we distinguish E from, my E and F apart? So 0 doesn't have F in it. 2 and 3, well, hold on. Should I be just saying for each segment? Maybe it'd be easier if I just said for each segment what numbers have it. Let's try that. For each segment, which numbers have that segment? All right. Which ones have A? Which for me is this top right one. 0, 1, 2, 3, 4. Everything but 5 and 6. Let's just write it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then B, which is this lower right one. 0, 1, not 2, 3, 4, 5, 6, 7, 8, 9. Oh, really? It's the only one that doesn't have it is 2? Oh, there we go. I think this is more promising. So C here is the bottom segment. So that's 0, 2, 3, not 4, 5, 6, not 7, 8, 9. Okay. D, which is the top one. We kind of already know which one that is, right? That's 7. So, but I'll just do it anyway. 0, 2, 3, not 4, 5, 6, 7, 8, 9. And then E is this top left one. So it's 0, not 1, not 2, not 3, 4, 5, 6, not 7, 8, 9. F, not 0, 1, 2, 3, 4, 5, 6, not 7, 8, 9. And G, which is the bottom left. 0, 2, 6, and 8. Did I do that right? 0 has F. F is the, no, it doesn't have. I'm looking at, I have to stick to my numbers here. So 0 is everything but F. 1 is just A and B. 2 is everything but E and B. 3 is everything but E and G. 4 is A, B, E, F. So A, B, E, F. 5 is everything but A and G. 6 is everything but A. 7 is A, B, D. 8 is everything. 9 is everything but G. There we go. I think I got it. Hey there, Spheres. How was your stream? How are you doing? I'm trying to solve Advent of Code 2021, day 7. I'm a little bit behind. I got part 1. I'm about a day behind because the day 8 unlocks, or no, we're doing day 8, sorry. We're doing day 8. I'm almost a day behind. Day 9 unlocks in an hour. So day 8 was about 7 segment displays and trying to like, given a bunch of input, trying to figure out which segment goes to, which position so that you can decode numbers. All right. What does this tell me? We can identify segment F just by seeing that, actually, if we knew which one 0 was, we know which one F was. I'm just looking at columns here. Six is missing A. So if we knew which one 6 was, we would know which one A was. Same thing for G for 9. And yeah, we can tell the difference between, we can know which one is D because it's because of this hole here. Right? D is not in a 1, but it's in a 7. And we know, okay, we know these are the ones we can determine for sure. That we know what the 1 is, the 4, the 7, and the 8, right? And then the other groups, I guess we'll call them like group A. It was 0, 6, 9, right? And then group B, or 2, 3, and 5. Actually, yeah, okay. So we know that we can figure out which ones are the starred ones, which means I can figure out which one D is because between the column 1 and column 7 we know which one is missing. What else do I know? Knowing which one 8 doesn't help anything at all, so I can discard that completely. What about 4? Does 4 help me at all? Yeah, 4 tells me which can distinguish between A, B, and E, F. We already have that here. Okay. Would it help if I arrange this with just the A's and just the B's? That's just the A's. And here we'll do just the B's. Did that help at all? B, C, D, and E are common, right? I knew this before. A, F, and G are what we figure out from that group, right? A, F, and G. That's what I had written down there. And this other group, it's 1 is missing from 5. No. It's more complicated. I don't know what to do. I'm kind of stuck. A tiny hint? Not yet. I'm noticing things like 2 doesn't have, every number has a B except for 2. B was the bottom right. Oh, okay, that's easy. I can look at, like, for example, they had this one line. Where is it? Where's their example line? This line. And I can figure out which one is missing from all, which one is in all of these but 1. And actually 2, we're looking for the one that's in group B, which has 5 segments lit. So between that one, that one, that one, actually they're all there, right? These are the ones that have 5 segments. Which one is missing from one of them? Actually, no, that's not the best way to do this. It's present in everything, so it's except for 2. So it's one of these 2, right? What's missing? Which one is A, B is missing from this? B. No, B is in there. Okay, now I'm confused. I confused myself. Successfully confused myself. These are all 5. That one has A, that one has A, and that one has B. It's missing an A. Oh, that's it. So A is B. Got it. Okay, so then let's write some rules down. These are the rules. So we determine which is D by checking. Well, this is the second rule. 1, determine which are 1, 4, 7, and 8. Determine which is D by subtracting 1 from 7. So by subtracting, I mean like taking out the segments that are in 1 from the ones that are in 7. That tells us which one is D. So then we can determine which is the rule I just discovered, which is B, by finding which segment from 1 is not in a 2, 5, 6. Which I guess is what a rule I wrote down here, right? So then that's the rules I have so far. We know which ones are 1, 4, 7, and 8. We know which ones are D and B. How does that help in this matrix here? We know this one, and we know this one, and we know the starred ones. I'll do some fancy ASCII art here. Whoops. I gotta turn off font ligatures for a second. There we go. Because font ligatures is messing up my ASCII art. So if we know which, so that means we know which one is A, once we know which one is B. Right. Determine which is A by subtracting D from 7. That's good. We figure out 3 out of 7 then. We know which one that is. Where are my tests? They're at the very bottom here. So the test input 26 was the number of easy groups, and then this is the what is it? They gave us the challenge of adding up all the output values. So these output values, and then figuring out what the output values and adding them up. But I haven't written the code for that part yet. I just need to get the rules first. What is it called when a chickpea is murdered? Homicide? That's worthy of Mr. Balrog. He's probably not here. I know you guys get frustrated when it looks like I need a hint, but it means I'm that close to having that eureka moment. Okay, so knowing A, B, and D, does that help on any of the other numbers? Well, we know 1 and 7 exactly now. Does that help at all? Between the A groups, I don't think that's... Okay, between the groups in B, we know that B is missing... We know that 2 is missing a B. So we can tell which one 2 is, because we can just find which one of the ones doesn't have a B in it, right? I think that's right. So we can identify the 2. Identify 2 from 2, 5, 6 by finding the one not having B in it. So then we've identified 2. So now among the B groups, it's just 3 and 5 that we don't know. I should have a just cheat sheet here. So we know which one is 1, we know which one is 2, we know 4 and 7 and 8, and we know segments A, B, and D. And knowing 2 and A and B and D, then the other 2 segments we don't know are C and F. Can't tell anything from that. Knowing a 4, we know E and F. Can I deduce something from that? Oh, yeah, I can. So between 4 and 5, 5 will have E and F in it, but 3 will not. So we can distinguish 3 and 5. So rule 6, identify 5 and 6 by finding which one has both A and B in it, which is 6. Right? Yeah, because we know A, B, but we don't know which ones E and F are. But if they're both in, of the 2 remaining things in the B group, we know which one is a 6 because we know it has both of them. And then we can distinguish between E and F that way because right. So once we know, yeah, I think I got it. So we will distinguish 5, and then we know which one 3 is, or not 5 and 6, 3 and 5. No, I did that wrong. 5 and 6. Oh wait, hold on? Back up. I don't know 5. Hold on. Oh, it's from 4. Right. And so it is between... No, it's not between 5 and 6. It's between 3 and 5. That's the bug I made. Oh, no, that's not right at all. Do I have the groups right? 2, 3, 5? Yeah, 2, 3... Okay, this is just making me... this is just confusing me. 2, 3, and 5 all have 5 digits in them. Okay, I was just getting myself confused based off something else I was writing. So, identify 5 by finding... Identify 3 and 5 by finding which one has A, which is 5, not 6. Yes. And that's E and F. Right. And then we can identify F. F from 3. Identify E and F. Since 3 does not have F. Since 3 has E but not F. So then we've identified, at that point, E and F. So then it should be pretty easy, right? In the A group, it's what's left. And the A group, we identify the 0 does not have F in it. I identify 0 from 0, 8, 9, or it's not 0, 8, 9, 0, 6, 9. Since 0 does not have F in it. Okay. So then the remaining 2... Okay, we know which one is the 6 because it doesn't have A. 6 from 9, since 6 does not have A in it. And then we know which one is 9 because it's the last one. And then how do we figure out between C and G now? What's an easy way? We can identify all the numbers. The segments. Oh, 9 doesn't have G. Identify G because it's missing from 9. Easy. And then the last segment we didn't know about was C. All right. So that would identify all numbers and all segments just following these rules. So those are my rules. I can delete everything else. Hopefully my rules are correct. I guess we'll be testing our rules with our unit test, right? I just need to code these rules now. And I don't need any of this stuff. So what really helped was having this and then the starter easy groups, right? And identifying the other two groups of 3 that we don't know yet. So that means that there's like a rule 1.5, right? Yeah. Which is determine which are 2, 5, 6 and distinguish 2, 5, 6 and 0, 6, 9. All right. Glad I gave myself like an extra hour to do this. It insists on putting a space there. What am I gonna do? I'm gonna do this. Find the correct key combination. Whoops. Why is it? Oh, because this is too long. There. So my line wrap doesn't get in my way. Okay, let's copy the rules into part 2. So we're gonna start with the same parsing, right? Only this time we actually want to collect into 2 different things, right? We want to do the complete procedure for every line after splitting it, so this is all different. So after we split, we're going to keep those 2. Let me just put this in front for now so I can see my types. Whoa. Why did it do that? I don't know. Why doesn't it list the whole type? Because it's too long? Yeah, it's tuples with 2 things in them. So for each one, I'm gonna want to split into groups, right? So left and right, for lack of better names. To left dot split ASCII white space and right dot split ASCII white space. I'm missing some syntax characters here. Oh, another parentheses? Yeah. Why is it putting it all the way out to the right there? Oh, because of inlay hints. Yeah. Split ASCII white space. That's giving me 2 iterators. I think I will just, on both of these, collect them right away. Well, map them. Group to group dot parse as I32 unwrap, and then collect them into vectors. So then we get a bunch of iterators of vectors. So then postfix is superior. So I don't like the infix inlay hints. Yeah, I'll turn them off for now. I kind of just want to make sub-functions here, right? So, these are our 10 digits, and these are our actual numbers. So what we want to do is operate on those digits first, run our rules through them to figure out which segment is which. And then knowing which segment is which, actually, we already know that they play a trick on us here, right? Where is it? Where is that example line? Here it is. So there's an example line, like we know that... where is it? Oh, no, they are consistent. No, they're not. So this one and this one are actually the same, but it's slightly like the order of the letters doesn't matter. So that tells me that the easiest thing for me to do without thinking too much is to use hash sets, because you can compare a hash set and then know that they're which one's which, right? So we're going to end up with like a vector of hash maps to say like which digit's which, and then we're going to compare this to each thing in that hash set. Well, we're just going to index, so hash set to really a hash map of hash sets to numbers. So let me just, because it's easier to do, make this let digits equal that, and then let display equal and then here I can, instead of just collecting them, I can map them. Group dot chars dot collect hash set, and I'm going to need to import hash set. What am I going to output though? What I want out of this, hold on. Oh, I didn't mean to parse that. Why did I parse? I don't know why I did that. This should be, yeah, forget that. I don't know why I did that. After mapping them into hash sets of characters, then I want to actually given, like, we'll have like a digits, if digits is the correct type, it'll be like digits. Can you index directly into a map? I think you can, right? Group. And then that'll give me the digit, and then for each digit we want to fold that together, right? Actually, we can reduce. How does reduce work again? I always forget reduce. It's like fold, but the first element is the initial. That's actually what I want. So I want reduce display. Is it given? It's given two things. So the next would be next, and it's display times 10 plus next, right? And then I want display out of that. So then it's just display. And then from that, I just want to sum them and convert the end to a string. Okay, so I just need to get the types right. So digits is a hash map of hash sets of characters to I32s. So this part's correct. All of this is correct. Oh no, we don't know yet. Need to import that first. Okay, this is almost correct. Can't index into a value of type hash map. Is it, see, yeah. How do you look into a hash map? Is it get? It's get. Group. Dot, unwrap. Borrow. Method get exists, but its trait bounds are not satisfied. It's not oh, you can't hash a hash set? Ooh. Well, shoot. I guess I'll make a new type that does it. So struct segment. Segments. Hash set of chars. And then impl hash for segment. Actually, can I just derive hash from that? Hash is not implemented for a hash set of characters. So I guess we got to do it ourselves. That's right. Yeah, it would have, of course we have to do it ourselves. Let's do it ourselves. What's hash from? He doesn't know what hash is. Standard hash. How come it... Fine. The control dot thing to import it didn't work. B tree set implements hash. So it does. There's an immutable hash set. Yeah, but it's more fun this way. Iteration order for hash set is undefined. I guess we're going to determine the order, right? Is this fun, or maybe I should do a B tree set? I think we'll do a B tree set. B tree set, because yeah, I was gonna say it'll be fun to implement hash, but I'm like, oh man, to get it to be predictable, I'll have to sort them and then add them or something like that. Or, you know, yeah, in a way that it's deterministic. And yeah, I didn't want to have to deal with that. Anyway, wait. Oh, right. This is a B tree set. Okay, now what's wrong with this? We need to dereference. Inlay hints would be helpful here. And next. Why can't I do that? Add reference here. Mismatch. Expects, wait. Oh, can I just do a copied? Then I don't need all these references. That would be simpler. There we go. If I just type that correctly. Okay, so if I can get the, if I can decode it, then this is how we... If I can make the decoder ring, then I can decode it with this. So let's make the decoder ring. So it's split, collect into vectors. No, collect into a vector. So yeah, we have to do a bunch of stuff. So we do that first. We haven't figured out the rest, so it's to do. Just making sure it compiles. It's not compiling yet. because this is well, it's unreachable. What is the error here? Annotations needed because it's unreachable, probably. Okay, so this to do, let's just say hash, for now, hash map new, just to get it to behave. Okay, what's wrong with my sum? Probably because, yeah, sum always seems to need to have a type there. Wait, what? That should just reduce inlay hints. Would help again? What did I do wrong? Oh, we get options? The reduce? Oh, reduce gives me an option. Unwrap that sucker. Then do I need that there? Yeah, for some reason it wants to have a type for that. The area could be empty. It won't be for us, right? So unwrap it. Okay, so how to apply our rules. Determine which are 1, 4, 7, and 8. Okay. And this digits is a vector. Oh, shoot. Before I collect into a vector, let's do this map. So this becomes a vector of B-tree sets. Okay, and then we're just going to go through and figure out which ones are 1, 4, 7, and 8 by simply searching for them. So what's the best way to do this? To make them all options to begin with? I guess. And then we'll all unwrap them together. 4, 7, and 8. Actually, I can just do digits dot retain, right? Because we'll just retain in the unknown digits the ones we don't know about yet, right? So we get to borrow a digit and do something with it. So if digit dot length is 2, then digit 1 equals some digit. Else, if digit length is 3, digit 7 is some digit. Else, if digit dot len is 7. 4 was 1, 2, 3, 4, yeah. Why am I typing all this when I can just copy paste? Else, return true, false, right? So 4 is 4, and 7 is 8. And digits needs to be mutable. And do I need to copy it? Do I mean make them copyable? What's the easiest way to do this? Maybe not do a retain, but reassign back into digits. That's probably easier, right? Let digits, and then we'll just dispose of the original digits. Digits dot filter and collect back into a vector again. Something like that. Into iter. And then I don't need to dereference that. It does escape. Why can't it escape? Do I have to move? Wait. What? Isn't this value type? Oh, it's not. Shoot. So I can't use filter. I don't know. I don't know how to do this. But we'll just do this into iter. Digits equals digits into iterator, right? And then you can say while let sum digit equal digits dot next. And then I don't need to do, well, hold on. Old digits. Let mute new digits is vector. We'll just do this manually. So this is new digits dot push digit, and then new digits. Why can't I call next? Next. Oh, this is old digits. It's going to tell me there's an easier way to do this. This could be written as a for loop. Yes, it could. Will it rewrite it for me? Oh, it was there. Come on, editor. There we go. And actually, I don't even need to. We can consume it directly. Never. Yeah, it's not read yet, but it will be. And this doesn't need to be mutable because we're consuming it. And yes, we're not using it yet, but we will. Oh, actually, knowing that, we don't need to turn it into an iter, so I don't need to collect it in the first place. We can just do that, right? Okay, and then, yeah, we'll fix this up later in a bit. So that's rule 1. Something tells me I should split these into their own functions. Okay, rule 1.5. Distinguish 256 from... Actually, we could have done that while we were doing this one, right? So let's have let mutable digits 256 equal vector new and 069. Then we don't need digits anymore. We don't need old digits. This becomes digits. And we don't need new digits either. Else, if digit len is, it's between 5 and 6, right? Then it's part of this one. Else, the only other possibility is 069, push digit. And then get rid of that. There we go. Getting there. Your part 1 score was 1500, part 2 was 13. Because you didn't want to do brute force using pen and paper to design algorithms is fun. I mean, I sort of used virtual pen and paper to determine the algorithms. I'm interested what you would consider the brute force technique to be. Okay, so then we did these 2 rules at the same time. Like we learned yesterday, or the day before yesterday, I'm not a really good algorithm designer, so this could be like horribly overcomplicated. Determine which is D by subtracting 1 from 7. Okay, so we have digit 1 and we have digit 7, and can we subtract B-tree sets from each other? Let's see if we can. Let D equal digits 7 minus digit 1. What does that give me? Oh, we cannot. Can I do like... Oh, no, these need to be unwrapped. So we should have something by now. So let's do this here. Let no longer mutable. Yeah, I know this is horrible. I know this is bad. There's probably a much better way to do this. Still, I cannot subtract B trees. So there's probably a method on a B tree like difference. There we go. Visits the values representing the difference, i.e. the values that are in self but not in other. Yes, digit 1. And then the difference will be what? Something I can do a next on? Aha! There we go. Now, it probably wants me to borrow that one, right? Cool. So now we know which digit is D. We can copy that. Can I just say char? Oh, it's by dereferencing that? Yeah, okay. Silly rules of Rust. You can narrow it down a lot? Probably. Did one solution you're pretty sure was just iterating every possible combination of segment mapping? Okay, so that was answering my question about what's brute force, right? You just try every single combination of 7 segment mapping until you find the one that makes sense. Sure. It's only a few possible mappings for each segment, just counting the number of segments. Well, we know which ones are 1, 4, 7, 8 right away just by the number of segments. Yeah. Is that what you mean? Some one weird lineage solution you didn't understand? Some wild lineage solutions this year? Counting the other way? Counting the other way like... Oh, okay. I'm lost track, but that's okay. I'm on to rule 3 here. Determine which is B by finding which segment from 1 is not in what? Something happened when I copy pasted that one. Oh, not in 2, 5, 6. That got cut. All right, so then which segment from 1 is not, so that's just doing a difference, right? No, it's not a difference. It's like... Hold on. Hold 2, 5, 6. And B was what? The bottom right. Wait. How did I get to that rule? Two, 5, and 6. Which segment from 1? How did rule 3 work? Should be set difference. Uh-oh, I'm dropping some frames. I dropped 47 frames. Okay, now I'm running into trouble because I don't remember what my rule 3 meant. Determine which is B by finding which segment from 1 is not in 2, 5, and 6. Well, one segment will be in 2, and the other B will be in 5 and 6. Only 1 of 3 and 2, 5, 6 light up B. Right, that and these two, right? Is that what rule 3 was meant to be? Is find which one only lights up one of the two, and not the. Well, that we know both A and B at that point, so we don't need rule 4, right? We know the two segments. We look between 2, 5, and 6. One of them will have one of the two, and the other two will have the other. So doesn't that tell us what both A and B are? And it also tells us which one is 2? So doesn't rule 3, 4, and 5 all go together? Can this be consolidated to find just like of 2, 5, and 6 find... Oh, wait. Wait, 2, 5... We don't know which one's 2, 5, and 6, though. That's from... We know 2, 3, 5. Did I miswrite that? Isn't it not 2, 5... Wait, I'm getting confused now. 2, 3, 5. Okay, this is wrong. 3, 5. Was this also meant to be 2, 3, 5? Or are my rules wrong? 2, 3, 5. I think I got my rules wrong. So the 2, 3, 5 group, one of them will have both of them, and that's the 3. Okay, I think I need to redo my rules. Yeah, I screwed up. I screwed myself up, but that's okay. I can just use the same technique as before. So we know these. Let's redo the rules. We haven't. We're not all is lost. We know which one D is. All right. No big deal. Knowing D. So, that actually gives me an opportunity to clean this on up, right? Okay. So yeah, we were on the right track there. For the 2, 3, 5 group, we can see which one is in, right? So determine which is 3 by finding which of 2, 3, 5 have both segments from 1. So that tells us this one. All right. Yeah, I use this numbering A, B, C, D, E, F, G. It's kind of arbitrary. Now I wish I hadn't deleted all that. I still have it up here. Let me get these original rules. Some of them probably still work. Yeah, mixed up, sorry. It shouldn't be arbitrary? I mean, I just need to pick some reference here and then be consistent in this. Okay, so what was the original idea? It was determine which is A by subtracting D from 7. Oh, because no, that's only if we knew which one. Where was it? This original rule 3. We said we could. This was the wrong rule, right? Determine which is B. If we knew which one B is, then we could find A by, yeah. So that rule goes away. Never mind. Knowing which one is 3, does that help at all? Then we'll know which ones are C and F. So I can look at no. I don't think that really helps. I'm not done. I'm still going. I'm probably going to run out of time at this rate, but you know, that's okay. I'm already a day late anyway, right? Really like to get, like, these all worked if I could distinguish A from B somehow. That's this trick, right? So if we know which one is 3, we know the other two have to be 2 and 5. How can we tell them apart? They both have D in them. I don't think we can tell them apart yet. One will have A and the other one will have B. How long have I been at it? And almost 2 hours. Well, actually, I don't know. I don't remember how much time I spent on part 1. You can use 4. That's true. 4 helps me to distinguish A, B from E, F. We only know D, and we know 1, 3, 4, 7, and 8 at that point. Maybe 7... No. Yeah, it's been live for 150, but we spent a bit of time solving part 1. Problem is, like, I know which ones are 2 and 5, but before I assumed I knew which group was 2, 5, and 6, but 2, 5 are from group B and 6 is from group A, so we don't know which one is 6, so that won't work. 1 tells you 3 versus 2, 5, and 4 tells you 2 versus 5. 4 tells me 2 versus 5. Oh, wait, I think I see that. So we can distinguish the AB group from the EF group. So then once we know which 2 are E and F, we can see which one of 2 and 5 have both. Okay, that's it. So distinguish EF from AB. By subtracting 7 from 4. And then determine which of 3, 5 is 5 by finding which has both E and F. There we go. So if we can figure out the EF group by subtracting 7 from 4, then we can see which one has both. That's 5. Then we know 5 and we know 2. Then I think we're back on track here, right? Because we just need to distinguish 0, 6, and 9. So, oh, once we know which one's which, we know A and B, right? So that could be the second one. Determine, well, right away we know which one is E. Determine E. Determine E, distinguish E from F. Well, determine which is E by seeing which of E and F is not in 2. There we go. So that does that. And that. And then the same thing with A and B. Determine which is which of. Now, do we know AB? Yeah, AB is what's left in 7, right? Determine which of AB 7 minus 1 is A by seeing which of let's abbreviate, is not in 2. I guess that's B. There we go. And then CG were the last ones, right? And we did it because G is missing from 9. Like that. Did I fix it? Let's see. Let's see if that makes sense. Identify 0 from 069 since 0 doesn't have an F in it. When we know which one is F from rule 7. Correct. So then, yeah, we know that. And then identify 6 from 9 since 6 does not have an A in it. Yeah. Which tells us all the numbers. And then identify G because it's missing from 9. And then that, let's see, is the leftover one. Okay, good. So we're back on track. It scares me. I have like 12 minutes left to do this. Or I might have to wait until I'm done with day 9. Okay, what were we on? Right, we have to toss the old rule 3. We have a new rule 3. Determine which is D by subtracting... Oh, that was... Okay, never mind. We already did that. We already did rule 3. Rule 4, please. Determine... determine which is 3, I guess. By finding which of 2, 3, 5 have both segments from 1. Alright, how do I do this? So... I guess I'll just do a loop. I guess I can assign back into 5. This is 2, 3, 5. We can assign back into 2, 3, 5. So let that equal, and then digits 235 dot into iter. Filter, right? Or am I going to end up with the same problem I had up here? I think I just want to do a... No, we'll try this. I hate it when it does that when I'm not done. Then I don't need this block, do I? No, I wanted to actually put it into... Okay, really, I need to do this. And I want to, flat... I'm thinking too... I'm tired. That's what it is. I'm also, I think I'm running up against some limitations in my knowledge of Rust so far. I want to put it into an iterator, and filter won't work because I can't take it out with filter. So really, I want to do a map group. And what do I want to do with that? I want to see if it has both segments from 1. So what's that? It's like group dot intersection with digit 1 equals digit 1. I need to make this make sense. It should be filter map, actually. If there's an intersection, and we should have let digit 3 equal none. Then digit mutable. Digit 3 equal group. Else and false. Else it's group. No, not false, none. Some group. And this goes back into digits 2, 3, 5. Okay. So yeah, I don't need the parentheses. Wait, an intersection is not a tree set? So how does this work then? I really have to do a cloned collect? Can I say just like if group.has or contains both of? Okay, I'll just do copied collect. Sure. Some. Really? Okay, fine. B tree set of somethings. You're using the digits to find the segments, but the problem only requires you to find the digits to get a solution, and no learned data needs to be shared between 069 and 235. But I need to know what's... So you're basically saying I don't need to do 11, right? I just need to identify which digits are which is true. So I could stop at rule 10. What did I do wrong here? It's not mutable. Why? No, I can't make it a filter because I need to move it out. If I try filter and I say false true, it's going to complain that I moved it. So I'm just going to silence this warning. It is a necessary filter map. Like Musin says, don't listen to Clippy. We'll clean this up later. Let digit 3 equal digit 3 unwrap. Alright, and then the next rule, distinguish EF from AB by subtracting 7 from 4. Let EF equal digit 7, no, digit 4 dot difference digits, borrow digit 7 dot collect B tree set. Okay, so then are these types all the same? What's... Ooh, no, I need to collect that. Wait, set of sets? That's not right. How did it get to be a set of sets? Iterator sets, and for each set, if that's true, then that group is a set coming out. Oh, yeah, this is the wrong type, vec. All right. 4 minutes to go. I think I'm gonna have to put this on hold to do day 9 on time. Yeah. All right, I'm running out of time. So we'll just get back to day 8, part 2. Let me just make sure this will actually compile and run with warnings. It's fine. Okay. Calendar. We have 3 minutes. Let me set up for day 9. Hopefully it won't be a train wreck like days 7 and 8. What am I saying? Of course it's going to be a train wreck. Main has... This is the chill part of the stream where I could use some framework to do this, but because it's like mindless busy work, it actually is sort of soothing. So, yeah, we're just getting ready for day 9 now. New file for 9.txt. Lib needs to have a mod for day 9. And day 9 can put 9 there. And then delete all the code I had from day 7. Put a big fat to-do there and there with one extra character gone. All right. Got 2 minutes. I need to hydrate. Hey there, Adam. I didn't see your chat until just a second. That's a good screen grab. No, it was just a big mess. My attempt to do part 2 of day 8. Yep, everyone should hydrate. You know, I should get me one of those huge bottles. I have this that Ski Dog has these, so I got one of them myself. They're pretty good. Although I think the vacuum seal is gone on it. All right, 1.5 minutes to go. What other chat did I miss? I missed TS Jost. How are you doing, TS Jost? Yeah, so AOC again. For those just joining, we're 1.5 minutes from unlocking it. Every day from December 1st to 25th, you get 2 programming puzzles. Sometimes they're a train wreck for me. Sometimes they're easy. And it just... We'll see how it goes, but it's all Christmas themed. They're pretty cheesy. The theme this year is that we've dropped the keys to Santa's sleigh in the ocean, depicted by these wavy blue lines up here, and we had to get into our submarine to chase down those sleigh keys. And we've been chased by giant squid and giant whales, and we've gone and crashed through subterranean caverns. And we don't know where at the end of day 8 where it leads us, but that's okay. We're just going to jump forward and pretend that we did all of day 8 and do day 9. You can do them in any order. The advantage of doing it right when it unlocks is that you can kind of see your ranking compared to everyone else. I'm not going to do this within the top 100. My goal is between rank 2 and 3,000. Time to get the maths book out. You have to do an A-level book. What's that? What's an A-level book? I do have an A-level book. From number theory? Might not be a bad thing. All right, so this is the first time anyone's but the puzzle creator has seen it. And so I'm level playing field with everyone else. Here we go! Day 9, Smoke Basin. These caves seem to be lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you, the puzzle input. This smoke flows from the lowest point of the area it's in. For example, consider the following height map. Each number corresponds to the height of a particular location. 9 is where it's highest, and 0 is the location where it's lowest. Flows to the lowest point. Your goal is to find the low points, the locations that are lower than any of their adjacent locations. Most locations have 4 adjacent locations. Locations on an edge have maybe 3 or 2. Diagonals don't count. For example, there are 4 low points. So the 0, the 5, the 1, and the 5, right? And 1 is in the bottom row. All the locations have some lower adjacent location, and so are not low points. The risk level of a low point is 1 plus its height. In the example above, the risk levels of the low points are 2, 1, 6, and 6. Okay, I feel better about this puzzle. I think I can do it. The sum of the risk levels of all low points is therefore 15. So that tells me, for this example, 15 is the answer. And the input is that. So we're going to put that in there and line all that up and try to calculate that. So input dot lines. I'm going to want to put this into a grid, right? So vector of vectors, I guess. So map a line to a line dot trim dot chars dot collect into a vector of characters, and then collect that into a vector of vectors. Let floor or height map equal that, and then we haven't done the rest. So make sure I have this so far. Vector of vectors of characters. We can make it a little bit better by turning the characters into numbers. So map each character into a character as U32 minus 0 as U32 dot collect. So now we have a vector of numbers. So then think about how this would work. So a brute force thing would just be go through and find all the places where there are no lower neighbors, right? Do I just want to start with that and get the answer? Because it's probably okay. So then for y in 0 to height map dot length, for x in 0 to height map y length, for n in, well, let's have a constant, what do we want to call it? Like neighbors, which is an array of I32s. Actually, I'm going to make this difference here as an I32. So 4 of those, right, equal minus 1, 0, 1, 0, 0, minus 1, and 0, 1. Okay, and so for n in neighbors dot iter, I think actually the shorthand for that is to just borrow neighbors, right? Right, so let mute, I don't know, down or lower. If how to do this? Let y2 equal y plus n dot 0. Let x2 equal x plus n1. If so it doesn't know the, oh, I can't do that because y is a use size, and okay, so then let's say as I32s. All right, and it didn't like that because I need to reference it as a use size. It's really picky about the types of integers. So if y2, if 0, really I kind of want this to be a constant. Let y range equal that, and then let x range, we'll assume that they're all the same widths. So I can just cheat and put a 0 in there, right? And then we can just say y range and x range there. Oops, I messed that up. Y range, No, that is correct. I had that right. Okay. If y range dot contains y2 and x range contains x2, then height map y2 x2 is less than height map yx, then lower plus equal 1, and we can actually break out of this. So if not lower, ultimately we want to count, right? Low points, what do they call it? Low points. Let mute. There's probably a much easier way to do this, but I'm doing it like almost the brute force way. If lower is equal to 0, then low points plus equal 1. And then at the end, it's low points. What did it want? 1 plus its height. So I can't just count the number of low points, right? The sum of the risk level. So I want the sum of the risk level. So let's call it risk. Then risk plus equal this number. 1 plus that. And it's just risk dot toString at the end. Okay, let's fix all my compiler errors. Cannot be in, right, so these are both as usize. Oh, there's a way to, is it iter? How do you iterate a range? Can you not iterate a range? Do I have to do clone and then into iter? I can't do that? Oh, this as32 is getting in the way. Can I just iterate? Do I have to clone the range in order to iterate it? That's a bummer. All right, well, I mean, that works so far so good. So X and Y are not the right types though. I32 there, we're cheating. And oh, really? Okay, I think it would be easier. Oh, that's right. That's where the I32s. Yeah, if the ranges themselves have the right types, then I don't need to do all this stuff. I still need this though. And I need to borrow here and here, apparently. Yeah, but when we index into that needs to be usizes because it's picky about that. Now, what's wrong with this one? Oh, that should just be Y and X. All right, let's see if I got it. Yeah, we got it. So then run 9.1. Oh, I don't have my input yet. That's not going to work. So let's grab my puzzle input. A lot of numbers. And we're going to put that in a new in 9.txt and run this again. 1,763. Close that guy. Uh-oh. That's not the right answer. If you're stuck, it didn't tell us if we're high or low. Part 1 done. Good job, TS Jost. Wrote out the rules for this one to help me. Adam. Risk is twice the height. Use size for Y2. Iterate a range. Clone the trim. See the n+1 rule. I especially appreciate the degree marker and the pi. I love it. Good job, Adam. Okay, so yeah, good morning, everybody. Romania hate. Anybody else I missed? So I messed up. Let's go return to day 9, figure out what I did wrong. This always sucks when the unit test passes, but then the real thing doesn't pass. That means like I was too lucky in passing the unit test. Right? So what did I do wrong? So maybe look at the input file to see if there's something about it that I didn't consider. I mean, it has adjacent numbers that are the same. This one did too, but I don't know. What else might I have done wrong? Don't know. So look for bugs. Risk starts out at 0. It's 1 plus that position. What's this lower again? Oh, right. If a neighbor position is lower than our position, x plus n1, y plus n0, x plus n. It doesn't really matter which one's x and y here. These are the neighbors, right? Okay, so then if it's the same, it's not a low point, right? Or is it? I wonder if they consider a low point if it's like two adjacent numbers that are both the same. So let's look at what they define to be a low point. Lower than any of its adjacent locations. Most... Okay, so then if like there were 2 5s here, would that be 2 low points? Or 0 low points? Don't know. Out of curiosity, can we like just print out x, yeah, x range? I forget, can you print out a range? Probably, right? Cannot print out a range. Doesn't implement display, but we can debug it, certainly, right? Ah. Zero to 100. Okay, so that's our extremes. And I'm considering the right edge, right? The length will be one past because we're counting from 0. Contains if it's contained in the range. So 3 to 5 contains, does not oh wait. What? Right, 2 isn't in 3 to 5, 3 is in 3 to 5, 4 is in 3 to 5, 5 is not in 3 to 5. Okay, so that's correct. Yeah, it did mention it's less than. I mean, I guess I can look and see. It's kind of hard to see, but like there's a 0. There's another 0. It's just kind of hard to see the non-zero low points. If there's no 2 adjacent zeros, there's no 2 adjacent, because there's a couple adjacent 2s there, but then there's a nearby 0. I don't think it's that. I don't know. I guess I can just have it walk through. Print here. Low point at XY. So it's not a ridiculous number. So let's see if that lines up with what I see here. 6, 0, 1, 2, 3, 4, 5. Yeah, there's a low point there, right? That 1, 7, 8, 9, and then another one there. I mean, those look right. 20 is there, right? Column 20. Yes. it gets me off because I'm off by 1 because the first column is column 1, which should be column 0. So 21, yeah, that 0. So I guess I should also print out what its risk is. Oops. And then sure. Well, I can be redundant and just do that, right? Maybe not. What is wrong with, oh, because I didn't put some placeholder for it. Oh, that's wrong. We have a 10? Why do we have a 10 in there? Okay, well, there's our bug. So there's it thought that there was a 10 was a low point. That can't be right. It can't be. So on column 61, 62. Oh, it's equal. Okay, so it's a 9 surrounded by 3 other 9s, and it's counting that as a low point. Okay, then I think I know what the problem is. It actually has to find at least one that's higher. So really, So we have to count higher. It would be nice if I just cached this, so I'm going to do that. Let level equal that, and then we can put level in a bunch of places. And then let's grab this one and say, I don't know, let n level, neighbor level, and put that there. And we need to say, we need to break up this if into 2 parts. We need to say if it's less than, else if the level is greater than, higher plus equal 1, don't break. If the lower is 0 and the higher is greater than 0. And what did I do to mess this up? Up here somewhere. No, down here. What did I do? Oh, it's extra curly brace. If can be written as match. Oh, that's true. Will it do it for me? Nah. It's like, you should do that, but I'm not going to help you. So it's match n level, compare level, right? Fill match arms. N less than level, it's this guy. Equal, nothing. Greater, do this. There. I don't know why I'm fixing compiler warnings right now, but I am. Okay, so test it here. It fails. Index out of bounds. Length is 5, but index is... Blah! How did that happen? Oh, we didn't test if it's in range. That's funny. Yeah, that should go there. Yeah. All right. Good thing we have unit tests, right? Run that unit test again. I didn't expect it to explode like that. Okay, so let's run it for reals. And we'll see if it... Yeah, so 633. Let's make sanity check. Make sure there's no 10s in there. Okay, I'm going to go for this one. Here we go. We did it. Continue part 2, because time's ticking. Next, you need to find the largest basins, so you know what areas are most important to avoid. A basin is all directions that evenly flow downward to a single low point. Therefore, every low point has a basin. Wait a second. Every low point has a basin? Basin is all locations that... Okay, so every low point has a high point? Is that what it's saying? Although some basins are very small. Locations of height 9 do not count as being in any basin, and all other locations will always be part of exactly one basin. Okay, I don't get it. Maybe from the examples. The size of basin is the number of locations within the basin, including the low point. The example above has 4 basins. Okay. Wait, what's the example above? Okay, the top left, basin size 3. Oh, I see. So it's the one that's bordered by 9s. Okay. Why didn't they just say the region bordered by 9s? Yeah, so it's a flood fill. That's all. We need a flood fill to the 9s. That's what we need to do. Find the 3 largest basins and multiply their sizes. Okay, so we can do this. I've done flood fill before. Flood fill's fun. Let's do flood fill. Ready? Let's do it. Okay, so first we need to find the low points, which we already have in part 1. So let's copy part 1. And since it's working now, we can remove the print lines. Print, remove them. Okay, so we don't need to know the risk, we need to know the low points. So then let low points equal I guess we'll just do this without doing function chaining because I'm tired. Low points is vector of somethings. Low points push x, y. Now it's a vector of tuples of integers. So then for, well, it's going to be low points fold, well, iter, into iter, fold. The initial would be, I guess, 0, because we want the sizes, right? 0, and then given, actually, I don't need a fold. I can just sum at the end, right? Actually, we want to multiply, so let's not do a fold. Let's just say map each low point. Actually, you know what I'm going to do? I'm going to just put the rest in a function because I feel like it. So this will be, what, area? Basin area or something? Basin size. It's not really an, it is, actually it is an area. And we need to let it borrow the, what did I call it? Height map. And the low point it can have. And then we're going to product it. And then to string that. Okay, so product works, right? Multiplying all the elements. Anti-iterator returns the one value of the type. What's the one value? Like the default value? I think product will work, but we'll see. So, function basin area, we're given a height map, borrow a vector of I32s, right? I think. And then it's the low point, which is I32. And then that gives us back I32. Actually, this can be use size because we're going to end up counting anyway. So let's just have 0 to return. Make sure it all compiles. It doesn't because product it doesn't like. Annotation is needed probably because I need to say product of use sizes. Let me just make sure it runs but fails. It'll say like 0 or something, right? 0. Great. There's the 0. Lovely. So let's fill in the function. So just because I don't want to think of a clever way, we'll just have it collect the points that we're in. So let mute visited hash set new, and then we'll say let mute border equal hash set new, and then border push or border insert, really insert. Oh, because it doesn't know what hash set is. Yeah, insert the value low point. Clone, well, copy. That'll copy it, right? So then I can say, well, actually, I won't need it after that. I can say while not border is empty. Well, and it will do. We'll be basically flooding from that low point out to the border, and at the end we want to know how many places we actually visited. So that would be visited dot count. Visit dot count, right? Or do I need to iterate and then count it, or length if we don't iterate it? Okay, so then we visit the border. So well, we take the first thing out of the border. How am I going to do this the best way? Just take the first one. How do we just get one at random? I guess if I don't use a hash set, it would be easier. Well, I need the hash set. I just need one thing out of the border. Can I just take one? Take is equal to the given one. Can I just take the first one? There should be an easy way to just get the first thing. Is it iter? Yeah, I can do iter, and then next, and then copy or something. Let point equal that unwrap, right? So that borrows from it, but I really want to copy that out. So what if I just say XY? And I just tell it I want an I32 so that it copies it. It'll figure this out, right? Maybe not. Oh, I can dereference to copy? Hey, that works. Then I don't need to tell it to type. What's its problem? Oh, it doesn't need... So yeah, so visited, we do it this way. Say visited.insert. Actually, we can just leave this as point. And then we can insert the point into visited, right? And then we basically... I say the word basically too much, don't I? My apologies. Oh, I'm gonna need to know all these ranges and stuff. Okay, we need that. We need to know all these ranges. We're gonna have the same kind of iteration. Similar thing to this. Yeah, and put that there. So for n in neighbors, well then let's let xy equal point, and then we look at the neighbor, and if the neighbor is on the map, then we look at the level, and if the level is not 9, if n level is not 9, then we put it on the border. All right, border insert x2 y2, but only if it's not already visited, because otherwise we'll be flooding forever. So if n level is less than 9 and visited and not visited dot contains, well, I guess we'll put this into new point, right? Let border point endpoint equal x2 y2. Then I can remove all this stuff. All right, so that's my flood fill. Let's see if I got it right. So we insert the low point. While the border is not empty, we visit that point. Then we see of all the neighbors, if it's within range and its level is not less than 9, then we, and we haven't visited it already, then we add it to the border so that we'll continue to iterate until we visit all the points, but we don't visit points that are at the 9s. Then at the end, it's how many things did we visit that length. I think that's right. So let's run the test. Oh, that's slow. It might be forever. I might have screwed this up. Yeah, it's stuck. Okay, so did I not? I must not have done my flood fill correctly. So let's debug. Can I debug visited? I can debug the point. And then I can run the test. Let's see what we get. Infinite stream of numbers? Yeah. Okay, stop it early. Okay, it's visiting the same place over and over again. That's bad. Why would it visit the same place over and over again? Oh, I have to remove it from the border when I do this. Forgot about that. Border dot remove point. Yeah. If we don't remove it from the border, it'll just loop endlessly. We got a number that was too high. Okay. But it does look like it's actually there's not a whole lot of things, so we can actually look at this compared to here. So it found the low point and it's 1 0. It visited 0 0 0 1 and supposedly stopped. We should have a debug when that happens, right? Yeah, it's probably gonna be helpful. So wherever that basin area gets used, where is that? Right click, final references, there it is. So like debug basin area. That'll work. Debug is our friend. Click that test. All right, here we go. So low point was 3. Oh, it didn't actually print out. Oh, no, that is the answer. 3, right? 3. And then blah, 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 9. And then blah, 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 14. And then blah, 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 9. Wait a minute. What happened to the 3? Oh, the 3 largest. I forgot that part. Okay. So I can't just multiply them. I have to sort. I have to collect the 3 largest. And I think I'm just going to do that by collecting them and sorting them and picking the last 3. So we don't do a product yet. We collect them into a vector of somethings. And we have to say let what is these basin areas, and that needs to be mutable because we're going to now basin areas dot sort unstable, and then it's going to be basin areas dot into iter. Let's let n num basins equal basin areas length, because then we can skip num basins minus 3 and then do product to string like that, right? Let's see if I get the right answer. Yep. All right. Run 9-2. Oh, I left all the debugging in, so that's going to slow us down. Which will finish first, the program or me removing all the debugging? The program ran faster than me removing all the debugging. Okay. Yeah, we did it. Let's see how badly I did. Remember, my goal is between rank 2 and 3000. It's probably going to be pretty bad. Let's see. Oh, look at that. Between 2 and 3000. This is surprising. So most people did part 1 pretty quick, but took more time to do part 2, I guess. Interesting. Well, good. I'm happy. I'm happy if I get between 2 and 3000 rank. Raimo just did something that I have to make a small video out of, and this will consume the tiny amount of free time you have left. Oh no, Adam's going to troll me big time now. I probably deserve it. That's okay. Your code is working with test input, but not real input? What, for part 2? Are you saying you haven't completed part 2 yet? No, TS Jost! You gotta give up the lead to me. Or, not me, T-Bod. But see, I haven't done 8 yet, so I'm behind even if you don't. Let me try to fix that by going back and doing day 8. Where was I on this mess? I was implementing my logic, my rules here, right? And I had ran out of time. I was on rule 5, distinguish EF, which I did. Only there are references for some reason. I think I meant to do copied. Now they're not references. Okay. Good. So next rule. I just need to codify these rules, and I think we'll be done. Determine which of 2 and 5 is 5 by finding which has both E and F in it. Okay, so then did I remove 3 from 2, 3, 5? I think I did, right? This is digits 2, 5. Can never beat T-Bod? Nope. Certain people you just know you can't beat, and just have to come to terms with that. Okay, determine which is 2, 5. Determines which is 5 by finding which has both E and F. So we can say it's kind of like this one, right? Let digit 5 equal something, and then let digit 2 equal something else, and then 2, 5 into iter, filter. Well, it's not really filter map. It's really find, right? It's really find. Or I can just say filter map next. Unwrap. Right? So this is horrible, but I'm gonna go with it. So it's the group intersection with E and F, with EF equals EF. Then that is 5. And unwrap it. Cool. So now we have 2 and 5. They're both B-tree sets. Nice. So next rule. Determine which of EF is E. Okay. Don't read, just copy paste. Now read. Determine which of EF is E by seeing which of EF is not in 2. Okay, so then we say same kind of thing, I guess. Let let E equal none, F equal digit 2 in iterate filter map. It's not of a group anymore. It's a digit. where it's a segment, if which of E and F is not in 2? Right, so we really want to iterate or really just take EF difference 2. Yeah, so can I just do that? So let E equal digit 2 dot difference EF next unwrap. That's E. And then let F equal EF dot difference I can't do that though. I have to make a hash set out of that. What's the easiest way to do this? Get rid of this stuff. I really just need to make some helper functions that'll do this for me. Hey, Adam's back. Video done. Heading out now. Don't watch it on stream, since it has copyright stuff in it. Okay, I will not watch it on stream. Can't wait to watch you make fun at my expense. Which of Adam's channels is it on? You'll have to read them all, TS Just. I mean, you're not caught up to date in all his channels. It's your fault. Oh, shoot. I can't think. Is there like a method on EF I can just say, like, oh, I can just remove it, right? I can just say, because we won't need EF anymore. I can just remove E. So we can say EF remove E, and then, yeah, I need to make it mutable to do that. There we go. Mutable you are. Let F equal EF dot next unwrap. I think I need to say iter. And reference. Okay. We did it. Rule 8. Yeah, when I clean this up, if I keep this way of doing it, I think I'm going to make helper like a helper type to help do these things rather than operating a B-tree set directly, because this is just gross. Determine which of A and B, 7 minus 1. So let's just get A and B equal digit 7 difference digit 1 dot collect into a B-tree map of stuff set. And I will want to copied on that. Yeah, so there's AB. Which is B by seeing which of AB is not in, and that got lost. 2. I'm sure this is how like Adam was going to make fun of me, right? Because my auto formatter like cut off some of my rules. There we go. So it's the same as this stuff, right? So let A equal digit 2 at difference not in. Actually, this is the other way around, right? I might have these two backwards. I should just go check right now. So which one is not in 2? E is not in 2. Yeah, okay, so then this should be F. And then that's F and that's E. So same thing here, probably A, B will be again in 2. Yeah, so B is not in 2. So A will be the difference, right? AB, next unwrap, then AB dot remove A, and then B, let B equal AB iter, next unwrap. This is horrible. Who wrote this code? Who wrote all this junk? Hey, at least the types are good. Okay. 3 more rules. Identify 0 from 069 since 0 does not have F in it. So it's really just finding, right? Which one it is. So let digit 0 equal digits 069 dot find group where group contains, not consume, contains F. Not. Did I get a reference out of that? Find. Probably because I need to iter before I can find, and then we will expect to find it, so I'll unwrap, and then I'll want to copy it out. So clone. There we have digit 1. Okay. Home stretch. 2 more rules. Definitely going to want to debug this though, right? Definitely. Oops. Deleted it somehow. There. Long, long function. Identify 6 from 9 since 6 does not have an A in it, so it would be, oh, I didn't, right. So we need to let digits 69 equal, well, you can say digit 069, remove digit 1. Why is it index? Oh, it's a vector. Shoot. How did I do this for these? Oh, I did a filter map. Okay. Yeah, I guess I can do the same thing. So, let digit 1 equal none. Let digits 69 equal digits 069 into iter filter map. If the group contains F, then it's some group. Else it's none, but then we assign digit 1 equal group. And then it's next unwrap at the end. Too many equal signs. No semicolon. Sum. Which means, yeah, I need to remember to do let digit 1 equal digit 1 dot unwrap. Mutable. Grumbles about mixing your X and your Y. Well, you're still ranked 3.8K. Does that mean that the problem was hard for everybody? I got a pretty good rank, even though it took me 36 minutes. We must be getting into the puzzles that are harder for most people, right? Well, no, day 4 was similar. Definitely harder than day 1 and 2, where within the first 10 minutes you got several thousand people. Or could it just be that more people did day 1 and 2? Who knows? Test works, re-input does not. Oh no, TS Jost. Did you do a flood fill? Maybe there's something wrong with the flood fill. Like, maybe did you count the first position? Sometimes that mistake can be made where you don't count the first position you flooded from. I'm slouching. I shouldn't do that. So the slouch detection is if you can't see my chin anymore. Oh yeah, it's going to tell me it's unnecessary, and I'm going to tell it, don't listen to Clippy for that one. All right. Identify which it is not. I did before, right? Oh, I did something like this. Let's do that again. Okay, digit. Nine, and digit 6 is the leftover. Digit 69. Group intersection with, oh, it's just A. Okay, so it's just group contains A. If group contain, oh, is group not, group is a character? Oh, this is wrong. It should be a, this is wrong. It shouldn't be a next here. This should be a collect. Hold on, I messed that up. It's just this. Yeah, okay. So then if it contains A, then it is 6. So let's reverse these. Then digit 6 is some group. Otherwise, we pass it through, it's a 9, because a 9 has an A in it. Next unwrap, and then 6 is 6 unwrap. Okay, so at this point we've identified every single digit. Right? We don't need to do rule 11. We don't care which segment is G. We know which digits are which, right? We have 1, 4, 7, 8. We have a, yeah, we have 8 is the leftover one. No, we know 8. We're just not using it. Never mind. We know 8. We know 1, 4, 7, 8. We know 3 and 5 and 2 and 6 and 9, right? Is that all of them? What about 0? Oh, this shouldn't be 1, it should be 0. I don't know why I said 1 there. Okay, so there's 0, there's 1 up here, there's 2. Looking for 3, there's 3. 4, 5. 6, 7 we knew, 8 we knew, and 9. Okay, so yeah, we know all of them. So then what am I supposed to, oh right, so then we just form the hash map. So then it would be array 0 digit, well, 0, I guess we just do it this way because it's going to be key value, right? Digit 0 0 1 2 3 4 5 6 7 8 9. 1 2 2 3 4 5 6 7 8 9 into iter and collect as a hash map. There we go. Okay, I'm definitely going to want to debug this, so let me just insert the debugging right now. So on all of these, I want to do a debug. Um, sure, I'll just know that that's D. I don't know how much to debug here. I guess we'll just go hog wild. Why not? I got time. Debug all this stuff. Okay, debug. This is 89 from 0. Debug here. And debug the whole dang thing, right? So all the way at the top, we debug all this entire thing. All right, and then let's run it through. Let's do it. It's gonna be a lot of output on this, or it's gonna crash. It crashed. Call unwrap on none. Let's say 173. Ooh. Okay, so we did have some debugging. Let's look at it. So our input back on day 8, part 2. It was this, right? Hold on. Is this Rust? Yes, it is. Hey there, time traveler. This is some awful Rust written by me. Because I'm not trying to make this the most elegant. I'm just trying to get the answer to Advent of Code 2021, day 8, part 2. If I get time, I'll clean this up once I figure out what the solution is. I just am going brute force to the solution on it today. Hey there, Ramy. How are you doing? Is this an EU-friendly time? Not quite. This is probably really early in the morning for the EU. You did catch me live. You caught me. Adam was here earlier, Ramy. Apparently, Adam has now made a video to troll me. It's 6:58. Yeah, good morning. It's a good Thursday morning, I hope. I should not slouch. You're a newbie to programming and you saw the RS extension? Oh, yeah. Yeah, RS is Rust, but you guessed correctly. Also, the stream title says it. So I'm trying to make sure that I'm figuring out the digits of a 7-segment display correctly. There's a lot to explain, but like you're given this like code and it's like, well, each of these is a digit 0 through 9 based off of lighting up segments. And your task is to figure out which segment's which so that you could figure out to the right of this pipe signal what these 4 numbers are. And then you find out what those 4 numbers are, etc. And then you add them up and you get the answer. So part 1 was just identify the 1s, 4s, 7s, and 8s, right? So now part 2 is identify all of them and count up the numbers and see what we get. So looking at this, the first part of it was to figure out the digit 1, which is the BE. Easy enough, right? 4 is the BC. Where is it? There's CGEB. I guess it's sorting them. Yeah, it's sorting them because I used a B tree set. Right, and then the 7 is the BDE, that's correct. BDE, but EDB, same thing. And then I can, yeah, the 8 is that. So the tricky thing is to figure out the difference between 7 and 1 is the D. Yeah, it is D, so that part's correct. And the next one is to figure out the, was it line 80? Figure out which one is 3 by finding which of 2, 3, and 5 have both segments from 1. Oh, we didn't show which one is 2, 3, 5. but it would have been the one that has 5 segments in it. So it says 3 is C, D, E, F, G. Did it tell us what it was? C, D, no. It was that one is a 3. So it got that one wrong. So how do we figure that out? It's which of 2, 3, 5 have both segments from 1? 1 is B and E, so it said, okay, that's wrong completely then. Yep, that's wrong. So this logic is wrong. Oh, wait, no, hold. Take it back. This is not 3. This is 2 and 5. 2 and 5 are those, and 3 is this one. Okay, so then it might have gotten it right then. So what is it? A, B, C, D, F. No, that's wrong. B, C, D, E, F. B, C, D. So that's 5. So okay, they got it wrong. So it thought it was 3, but it's actually 5. So what did I do wrong there? Digit 1 is BE. So which one has B and E in it? 5. Oh. Shoot. I got that wrong then. That rule is wrong. Dang it. Both segments from 1. Wait, did I do that wrong then? No, that is 3. So it'd be A and B. And oh, their letters and my letters are not the same. Okay, yeah, I get that. I keep getting that confused. Right? A and B are in 3, but the real input had B and E, not A and B. So yeah, I'm just getting it confused. So that's probably right then. Let's go back. Where am I? I don't know where I am. What happened? I closed it, I guess. Okay, so I gotta run it again. Run it again. Okay. Right, that has B and E in it. So that's 3. Okay, and then what's line 99? E and F is, which one's 4 and which one's 7? So E and F are C and G. Is that right? See, they don't print out which letters are which, so it's hard to say. So let me just skip that for a minute. Determine which is 2 and which one's 5. So it says that 2 is A, B, C, D, F. Well, what did they say 2 was? G, C, D, F, A. It's confusing because this line, yeah, A, B, C, D, F, that's 2, right? No. Oh, that first line doesn't match the test's first line. Yeah. I'm gonna have trouble comparing this with mine. So F is A, E is C. Oh, that's bad. Oh, no, that's okay. No, that's bad. I can't do that. I don't want to do difference. It's not 1 minus 7. It's 1 intersection with 7. So that's the problem. Intersection. Okay, that was wrong. So that probably led to an unwrap problem down here. Yeah, on line 173 when I tried to separate them. Yeah, okay, well, let's run it again. That was a bug. Okay, there's another bug somewhere. Okay, B and E are, yeah, okay, that's good. 135, or A and B are B and E. A is, or 2 is, what is this? The difference. That can't be right, can it? If A and B is BE, then that can't be right, AB. You rewrote the entire code, still got the same incorrect. I'm sorry, JS. So now you know how I feel, where I like spend 2 hours and can't get the answer. But as the creator of AOC has said, as long as you're learning and you're having fun. If you're not learning and you're not having fun, then I would just put it down. come back at it fresh another day. What did I do wrong here? So 7 is BDE. BDE is 7. So that means that AB is BE, because D was, right, okay. Wait, why did I have digit 2 there? Oh, because not in 2. I don't think this is right. 2 is what? $108. Yeah, this is 2. A, B, C, D, F. A, B, C, D, F. A, B is B, E because D. Yeah, I'm not explaining it very well. So there are the characters that come in, and then I am trying to map the input characters to the output characters, because the wiring is the whole premise behind the day 8 is that there's 7 segment displays, but the wirings are randomized. So I picked an arbitrary output naming convention, A, B, C, D, E. I just took what they showed here, and then we're taking the input characters and trying to find out, like, is the input character A, which one of these is A, right? So I should say A input equals what output. So like A input could be D output, and C input could be F output, so you have to figure it out. They lined it up so that these characters actually match this display. Like A, B is 1 because it's those 2 segments, and then 7 is D, A, B. That draws a 7, right? And 0 is everything but F. So that's probably in here somewhere. Like there's 0, right? So my variables like EF and F and E, those are my output letters, and the input letters are what being shown in the debugging. So I know it's hard to make out. In fact, it's hard for me to read it, so maybe I should think about printing this differently. But I don't think that this is correct here, the one on 135. Seven and 1 intersection. I think it's not a 9 is part of a basin. We solved day 9. I'm going back to day 8 because I never finished it. Yeah, so sorry for the pause. I did day 9. Here's my rank for day 9. Wasn't too bad. Day 8, though, I didn't start until today because I couldn't do it last night. And good thing, because it's taken me like hours to do it. So we're going to be like over 24 hours a score, or basically really abysmal rank, but that's okay. So this intersection here, BE, that's correct. Because 7 was 1 is BE. Wait, why am I getting the intersection? This is wrong. 7 and 1 intersection is 1 by definition. So, okay, then I wrote my rule wrong. I originally said 7 minus 1, which is not correct. So what did I do wrong in my rule here? Oh, it's not 7 minus 1. It's 7 intersection with 1. So which is just 1. Yeah. Which of AB, which is 1. So it's just 1. There's no difference or intersection or any of that stuff. Which of AB, 1. So I don't even need to do that. I can just say digit 1. I don't need an AB. Except for I did that to get... let's just say AB equals digit 1.clone. That makes it easier. All right, so let's run it again. Not sure if your code is counting some locations as being part of 2 basins. No, it's impossible for something to be in 2 basins because there is a ridge. Think of there being an impassable ridge of mountains of 9s. At which point do you start writing a function that prints out a segment? Soon, Zeezer, soon. So the basins don't merge together. The basins are everywhere you can get to by flood filling the low point. Think of it backwards. Think of the low point as being the origin, and then it spreads out to the high point, and it stops. It stops at all the 9s. So that's why it's not working. So you had it backwards then. Yeah, okay. Well, now you know how to fix it. So, and knowing is half the battle. Okay. Soon I will print out the segments because this debugging is kind of miserable. Okay, so where was I? It was 135. Right, so that can't be. Oh, I guess it can be. What is digit 2? It's the other way around. It's AB difference digit 2, really. That's what I'm doing wrong. If AB difference digit 2. That's, yeah. Okay, I had it backwards. Most of the time when you have bugs, it's off by one, getting something backwards like I just did and what TS just did. Part 2 done. Good job, TS just. No, you never said that? What did you say? At what point do you start writing a function that prints out a segment? And I said, I'm going to do it soon because printing out the segment... Oh, you don't mean printing out how the segments map. You mean like printing it out on the screen. I don't think we need to do that, but that would be kind of cool. Hey, with the borrow checker, is the only advantage you can avoid memory leaks? No, that's not the only advantage. The borrow checker helps you also catch where you... It's one of the components of catching concurrency issues. So the idea that you can accidentally borrow something across two threads, or that you could pass something to a thread and then it ceases to exist because the sender destroyed it. So elements of that get into the borrow checker too. But some of that is also caught by traits like send and sync. So there's no cut and dry answer about like what exactly the borrow checker does. It contributes to many different compile time checks. You know what I mean? You blame bad puzzle. Yeah, that's always a valid way to handle this. Just blame it on the puzzle description. Okay, I forgot if I ran this or not. I did. Okay, so what's the deal? Is it getting further? No, it's not getting much further. Digit 2. Okay, that's probably wrong. It's for the same reason that the other thing was wrong. Yeah, this is again, it's EF difference digit 2. And that's correct. I got that correct, but not the other one. Interesting. Okay. Run it again. Still panicking. I think it's getting further. Or I'm getting confused. No, it's not getting further. 136. E and B. Okay. That's 6 and 9. 0, 6, and 9. Okay, that's the problem then. It never found the 0. So what is F? F is what? We found F on 129, so G. So which one doesn't have? They all have G in it, because that's a problem then. A, B, D, E, F, G. A, C, D, E, F, G. And okay, so that's... They all have G in it, so G can't be the... They all have the segment, so that segment can't be the middle segment, right? So where did we screw up on that? 25. 43. This is wrong. Why is that wrong? Oh, do I get these backwards? That should be E and that should be F? Let me verify. Rule 7. Two does not have E. So the difference would be F. Yeah, that's correct. 99. C and G. Okay, really what I need to do is work this out, work this first line out on virtual paper, and then compare with my debug output. So let's do that. So I'm going to take this first line, and we're going to work it out. All right, so doing our own rules, right? 1 is BE. 4 is C, that, and then sorting it, so G, C, E, G. B, C, E, G. And then 7 is B, E, D, E. 8 is this long one. Well, it would just be A, B, C, D, E, F, G. That's always the case, right? We don't really need to do that. It's always going to be that. Anyway, so then the next rule, I should close this for now. The next rule is that 2, 3, 5 is all the ones that have 5 in it. So yes, so it's this one and these two. So sorting that would be what? C, D, E, F, G. B, C, D, E, F. And A, B, C, D, F. All right. Then 0, 6, 9 are these longer ones. And that one. So B, C, D, E, F, G. A, C, D, E, F, G. And A, B, D, E, F, G. Okay. Then determine which is D by subtracting 1 from 7. So that's D is I guess we'll use, to disambiguate, we use capital D instead of lowercase d. So output D is actually D, right? Lowercase d. Oh, I think these are arranged. We picked this arrangement to match this first line anyway, right? Anyway, we'll find out. Determine which is 3 by finding which of 2, 3, 5 have both segments from 1. So which one have B and E from here? Wait, what? That's not right. Oh, no, this one. Which one? So that's 3 is B, C, D, E, F. And then distinguish EF from AB by subtracting 7 from 4. So that would be C, G. EF is CG. All right, I'm following my own rules to see if I get it right, and then I'll see if my program got it right. This is what I should have been doing before. Determine which of 2, 5 is 5. So that's so 2. So I should have said that means 2, 5 are the ones that don't have 3 in them. Dang it! I keep hitting the wrong control character. It's not this one. Okay, so now which of these 2 is 5? But find which has both E and F in it. So E and F is CG. So that's this one. So that's 5. 5 is that one. That means 2 is the other one. Then determine which of A and B, which is 1, is B by seeing which of A, B is not in 2. So which one of these 2 is not in 2? 2 is that one. It's E. B is E. So that means the other one is A. B. So then identify 0 because 0 does not have an F in it. An F... We didn't determine which... Oh no, oh, I didn't do this one, did I? I skipped that one at some point. This one, I skipped that one. Determine which of EF is E by seeing which of EF is not in 2. So EF is CG, so it's G. E is G. That means F is the other one, C. Okay, so then 0 doesn't have C in it. So of these ones, which one doesn't have a C? That would be this one. That means 6 and 9 are the other two. These two. And then the last rule is 6 does not have an A in it, or a B. So that's this one. 6 is that one, 9 is this one. Okay, so then I need to compare this with what the debugger told me. So 1 is BE, check. 4 is BCEG, check. 7 is BDE, check. 8 is ABCDEFG, of course. So then 3 is BCDEF, check. 5 is CDEFG, check. So GC and EB, correct. So then, okay, so it couldn't filter out the 0 from 069 somehow. So F. Let's double check that I got that correct. So 129. So it says that capital F is G. Oh, I got it backwards. Okay. So then it's the other way around. That's E and that's F. Try that. Passed. All right. Why didn't it print a bunch of stuff though? What happened to my debugging? Wait, did I really pass or did I run the wrong thing? I ran the wrong thing. Dang it. Dang it, Bobby. I ran the wrong thing. Got my hope up. Okay, so where were we? Okay, 0 is A, B, C, A, B, D, E, F, G. That's correct. Okay, so it got 0. Okay, we're really close because it figured out all the way to 0. So then it's panicking on 170 way at the bottom here. So it's this one. Figuring out which one of 6 and 9 is 6 and 9. Digit 6, 9, where are those? Okay, are those 6 and 9? Let's see. A, C, D, E, F, G, and B, C, D, E, F, G. Yes, that's correct. So then what rule, how did I do this wrong? 0 doesn't have an F in it. Oh, this is backwards then. It does not have an F, so so I have these swapped. There. Try again. We'll get this eventually. It's still a panic, really? This is still wrong. Wait, it should have printed something there. Oh, this is wrong. Oops. It dropped something now. What did I do? 143. Oh, no, that was correct. I did the wrong one. This one is right. This one is incorrect, right? Double check. Yeah, A. Which one doesn't have A? Okay, I'll get this before midnight, I hope. Do you guys like watching me struggle? Probably not, but you know, there are ups and downs to everything in life, right? So which one was A again? A is 136. E. A is E, right? No, those are backwards. Okay. These are backwards. That's a B, that's an A, remove B. That might explain it. Okay, so run it again. Okay, now what? $71. Okay, so it figured out what 9 is, but it couldn't find the 6. A is 136. 138. B. A is B, right? Yes. So then digits 6, 9, which we already know is 143. These two, which we already verified, doesn't have B in it. This one, A, C, D, E, F, G. Oh, what am I doing? This should not be 0. This should be, oh, sorry. Is that the line that it panicked on? 171, yeah. Digit 6 is some group. If group contains, it did filter it out. So what happened here? It did filter it out. So it's 6, 9 does have 2 groups in it up here. And then it only has 1 group left here. It should have put the other group into digit 6. And then why did it panic when it unwrapped it? I don't get it. What am I missing there? It should have stored it there and then unwrapped it there. So why did it not? Okay, I don't understand this. So I'm going to do something like more debugging. Actually, I can debug the whole thing, right? Yeah, debug all the things. Actually, that just debugs the outer expression. Wait, it only went in once? Oh, hold on. I think I might know what I did wrong then. This digit 69, where is that? That's here, right? Well, that had 2 things in it. What did I do? Or what did it print on line 140 for 143? Ah, dang it, I closed it. Should just get rid of this one. There are definitely 2 groups in there. 1 group and then another group. Going into, on line 143. So that goes into digit 69. And then we put that into an iteration, filter map, and then we should print twice, 162 twice. but it only prints it once. Why? Oh, I know, because once it went through once, it stops. I can't, okay, then that's a problem. I can't do this next unwrap business. Because it'll stop on the first one. I have to iterate it completely. So... yeah, I have to collect it completely to the end and then take the first one. So collect vector of somethings and then just take the first. Unwrap that one. Yeah, I need to do that, and wherever I have this next unwrap, I need to do collect and then first. What's wrong with digit 2? Not the right type. Uh-oh, my inlay hints are broken now. Hold on. Oh, okay, it's a reference, so shoot. Oh, I need to do, not first, really just index the first, so something like, that. Yeah, okay. Collect and then index the first. No? Come on. Cannot move out of vector. Shoot. You know, okay. Then into iter. Next unwrap. Please give it to me. There we go. Into iter. Next unwrap. All right. Please work. Please work. Please work. Oh, I think it's working. Only gave me the wrong answer. Okay, that's good, I think. Let's go to the top. Oh, I can't see the top. Shoot. So it's too much debugging. How do I do this then? Have it go only one iteration in here and just panic. So do that once. So instead of sum, just do like, yeah, I'll just, instead of doing sum, I'll do next unwrap. Just do the first line. I can verify the first line is correct at least. 8364, is that what it was? So calendar day 8 part 2. Says it should be 5353. Did I do that right? Those are definitely different digits, so... oh yeah, 83, here it is, 8394. Okay, so the 9 and the 6 got mixed up. Okay, 9 and 6 are mixed up. We can fix that. I'm doing a lot of flipping the two, right? So this should be 6, and that should be 9, and this should be 9, and that should be 9 and 9. Right? And then run. $63.94. Okay, so then let's have it skip the first and do the second. So to skip the first and do the second, that would be skip 1. So now we're going to compare the second line. 9781 and 781. Okay, good. So then do we just go for it then? So to go for it, I would put the sum back in there and then just have it run. Oh, it passed. Okay, cool. So then remove all my debugs? No, not yet. Let's just have it run. CD 2021 cargo run 8-2, right? Yes. Too much debugging. Okay, too much. So, oh no, there we got an answer. 994,266. Let's go for it. Yes. Woo! All right. So glad that worked. Greater than 24 hours ranked 41,000. I was the 41,539th person to solve it. All right. So, got the correct answer. Now we can move on to the stage of just cleaning the hell out of it, right? Cleaning it up. So we can get rid of hash set and ops range bound since we don't use that. Yay! What is that? Hype hands 2. Yay! Let's clean up stuff. So it looks like I never needed to know what D was. So we can drop rule 3 completely. All right, let's drop rule 2. Drop rule 2 completely. That really is rule 2. So we dropped rule 3. We didn't need rule 3. What else does the compiler tell me? Okay, the compiler doesn't have any other warnings. So let's get rid of the debugs. So that match is way the heck down here on that. No, on that. Okay, and all of these debugs, we can kill those. This debug goes to there. Just cleaning up all the debugs now. All these go away like that. More here. These two go away like that and that. Okay, this is like that and that. Okay. Apparently I didn't need to collect this. Because why? Because we just ended up putting it back into an iterator. So we can drop the collect and get rid of drop the into iterator. Broke something. What did I break? I can't even see what it is. I don't even know where the error is. I can't even see it. It's right here. Oh, here it is. It's digit 3 is borrowed. Digit 3 is borrowed. Why is it borrowed here? Wait, what? Wait. Borrow occurs due to use in closure. Borrow is later used in 98. Oh, right, because this is a lifetime thing, right? So this is an iterator. It still holds on to this this thing, so we can't assume that that's complete unless I collect it. So I guess I'll put the collect back in there. And there's probably a better way to do this, but we're doing the collect so that we know that we've filled in digit 3. Otherwise, we don't know if we have. I guess another way to do it would be to collect, to get digit 3 down here. Yeah, we can do that. Although it's more obscure. Actually, I'm going to leave it like this for now. We'll just hide the warning. Clippy's like, yeah, you don't need to collect it, but I'm like, I do if I want to resolve digit 3 at that point. Right? It's an obscure thing. Obscure iterator thing. Let's make sure I didn't break it. Yeah. All right. I'm being rated by Vulpes TV. Hello. I'm cleaning up my Avena Code 2021 days 8 and 9 solutions. They're quite messy, so there's going to be quite a bit of cleanup to do. Day 8, I didn't do until today, even though it unlocked last night. And did day 9 today. Struggled a little bit, but got a decent rank. For me, a decent rank is between 2,000 and 3,000. So that means 2,533 people did it faster than me. I don't care. I don't do things fast. Got pretty stuck on part 2 of day 8, though. And my solution is really, really a mess. So I'm trying to clean it up right now. Fast is overrated. Yeah, I agree. So, what I ended up doing to solve, I don't know if you've done this puzzle before, but let's go. Calendar, day 8. So, day 8 is about deciphering 7-segment displays. And they tell you that the wires are randomly crossed. And so you end up with, like, here are the 10 digits. Figure out which segment is which in order to figure out what digits these are, and then do that for every line and then add them up, right? So in order to, like, given this, figure out which segment is which and which digit is which, I invented these rules, which we came up with just by starting with what we knew, which is that there are 4 easy digits. That was what part 1 was about. Where does it say that? Digits 1, 4, and 7 have a unique number of segments. So, like, if we refer to this diagram, only 1 has 2 segments lit up. Only 4 has 4 segments lit up. Only 7 has 3 segments, and only 8 has all 7. So you can figure out which ones are 1, 4, 7, and 8 really fast, but you still don't know which segments match, right? Which segments are actually A, B, C, D, E, F, G in this diagram, right? You can distinguish the groups of digits 2, 3, 5, and 0, 6, 9 because 2, 3, and 5 all have 5 segments lit, and 0, 6, and 9 have 6 segments lit. And then from then on, like, what I did is I filled in, like, with arrows here what I knew for a fact at that point, and then I'm like these are all like inferences. So there's probably a more efficient way to do it, but you can infer which segment D is by comparing 1 and 7, and you can see, like, 7 has an extra segment lit, so you just see which ones in 7 are not in 1, right? By subtracting the 2, if you consider them as sets, right? So that tells you which segment D is, so then you put an arrow at D, and then these other rules I just figured out through inference until... we don't need to actually know what all the segments are, but we do need to know which digits are which. We start by knowing 1, 4, 7, and 8, but we have to figure out which ones are 2, 3, 5, 0, 6, and 9. Those are the harder ones. And then I tested my logic because I had a whole bunch of bugs. We took one example line and I ran through my own rules to figure out which digits are 0, 6, 9, 2, 5, 3, and then 1, 4, 7, and 8 are the easy ones. And we have code to do basically this rule set, and then do that for every line. Once we decipher the which digits are which, go back and we take the 4 digits that are after the pipe symbol here, and we use our decoder ring to figure out what they are, and then we take all the numbers from all the lines and we add them up to get the answer. So like they gave us for this example input, here's the example output, and that's what my unit test is about. For part 1, it was 5, where was it? We're on the right day? Hold on, why does it say, oh no, that's my actual answer. There, the example answer was 26 for part 1. And for part 2, it's this 61229 right there. So we make sure that we can solve the same example the way they did it, and then you get your actual puzzle input, which is much larger than this. This is the example, right? The actual input is much larger, and that's to make it prohibitively expensive to do it by hand, right? So the actual is 200 lines of digits, which would take quite a while to do by hand. Hold on, let me scroll back. You're not doing Advent code, you just want to focus learning Rust? Okay, I have a lot of examples of different Rust here, good and bad. So let me know if you have any questions. Yeah, you guys probably have much better solutions than me. That's okay. There's a solution on Reddit that's pretty epic, just by dumb luck, really? Oh, the super thread for Advent code, that looks right. Simple, fast, and deterministic numerical approach for day 9 or 8. Because remember, this is from yesterday, not today. Can you send links? I don't think you'll get timed out. I think I'll just have to approve it. And if you get banned, I'll unban you. I don't think you'll get banned. I think it's just, I'll have to approve it. You'll see, there you go. Yeah. Should I take a look and peek at that? Okay. Start by taking each segment of the display. Assign it a score based on the number of digits in which the segment will be used. Oh, I see. So you just use statistics to figure it out. Sure. Wait a minute, is it deterministic? Or is it just... Oh, it is deterministic. Wow. Oh, is that because if I didn't consider that. So, yeah, if we go back to this diagram I made, right? No, not that I made, that they made. Here, right? Like, how many times do we see A? 1, 2, 3, 4, 5, 6, 7, 8. Let me write that down. So A is 8 times. What's B? 1, 2, 3, 4, 5, 6. B is 6. C is 1, 2, 3, 4, 5, 6, 7, 8. See, already you'd be hard to distinguish A from C, but it was a good shot. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And G is 1, 2, 3, 4, 5, 6, 7. So you could, if I sort these, you can figure out which, yeah, so you could just count them and you know which ones segments E and B are right away, and F. And then you just have to disambiguate A, C, D, and G. Is that what they said? If you do this for every digit, you'll find they yield 10 unique numbers. Okay, they did it slightly different then. Take each digit, add up the scores of all the segments used to create that digit. So A uses C, which is worth 8, F, which is worth 9, total 17. Oh, I get it. So these are the scores, and then, oh, that's pretty clever. I like that. So yeah, so then it's, you calculate for each number, etc. I won't do them all. The scores, right? So 0 is everything but D, so it's all these numbers minus 7. Right? So Yeah, actually, it would take too much time for me to do because I'm bad at doing math in my head. But yeah, so you get some unique number, which is all these -7, and then 1 is 17, etc. And so then you can identify each digit by that score. Yeah, that's pretty cool. I wouldn't have thought of that. That's too clever for me. It requires no inference, but it's more upfront mental work. Yeah, well, it's the insight that scoring the segments and then scoring the digits, like, isn't there a mathematical term for that? Like convolution or something like that? Or am I getting my terms mixed up? So you're like, it's like kind of like hashing. You're getting a unique hash code for each digit, and then you're just comparing hash codes in the end. I'm being rated by Griffing and Chill. Hey there, Mr. Sir. Doing the inference was fun. Yeah, I had a blast coming up with these numbers. What really sucked was that I had so many bugs in the implementation of this. Howdy, Mr. Sir. Yeah, we did Avena code, and this is a post-mortem. I did day 8 today. It actually unlocked yesterday. It had to do with 7-segment displays. So, Mr. Sir, you should try out these puzzles. Some of them are pretty clever in how you solve them, and some of them are pretty baffling and difficult. Best question this month so far was day 8? Yeah, day 9 was a little bit easier, right? Day 9 was about flood fill, right? When I saw this, I'm like, dude, it's flood fill to the 9s, right? See that? Easy. And the first part, there's probably a clever way to find the low points here, but I just brute forced it. I'm like, what the heck? Why be clever here when the input is not that big? Well, Sarian, my day 9 is probably slow too because I just did brute force. You want me to bench that? Let me make sure I'm not printing anything at least. Cargo run 9.1. Let me make sure it's not printing anything. Okay, 9.2 is printing something, so I need to clean that up. Debug. All right. Just cleaning up the print so that I can get a fair benchmark. All right, so then I probably didn't fill in the runner for the benchmark for 9. No. I did 8, though. 9. You know, even when I struggle, it's when I get the solution finally that it's all worth it. Even though I maybe spent 2 hours and probably bored a bunch of people and lost people watching, it all makes up for it when I get the right answer, and then I can go back and kind of post-mortem, like, improve it, compare it with other people. 40,000 iterations means it's going to be pretty good. 127 microseconds for part 1. And part 2, it's going to be slower. Probably my flood fill could be improved, right? 2 milliseconds. So when you say 900 microseconds, is that parts 1 and 2? Say part 1 is the same as yours? Yeah, part 1 was 127 micro. So I don't need to get much further to get down to yours, right? I just need to maybe find some slice off maybe 50% of it somewhere. 900 for part 2. Yeah, okay, so that's maybe a goal to try to achieve tonight is improve the performance of part 2 of day 9. How do we do on the 7-segment display? Oh, this is going to be really good. When it says 192,000 iterations, that means it's pretty fast. 25 microseconds. And then, so you can see it, 25 microseconds and 2.25 milliseconds for part 2. 25 micro, 2.2 milliseconds. Did I do it recursively? No, so that means neither of us did. Recursive is likely slower? It depends. Recursion is really just a loop using the stack when you think about it. which has some pitfalls, right? If your stacks are typically only a few megabytes in size, so your recursion could easily blow your stack. Day 9 for you is 275 nanoseconds, 97 microseconds. So I have a ways to go then. I'm like an order of magnitude slower. But I did a whole bunch of laziness, right? This chunk with these are like all unnecessary. It's just I needed to have some quick way to do it. If I make a custom type other than B-tree set, I could probably make this a lot faster, because we only have 10 digits and we only have 7 characters. So I can make a special type that, instead of using a B-tree set, just does something quick and easy. Your day 8 part 2. Why did I say 3? Maybe I'm dehydrated. There's like no 3 in that. See, if I look at your solution, is it going to taint my brain so that I end up rewriting my day 8 to match yours? How about I'll look at your solution after I have a go at improving this performance. Let's remove all this. I kind of want to keep this original thing and maybe move it to the top. Yeah, we'll take this. Actually, you know what? I'll take this and mark that this is example. This was extra stuff here, right? Yeah, that was explaining something else. So I kind of want to move this to, I don't know, part 2, I guess. No, let's move it to the top. Let's put it up here. So this is 7 segment display, and this is inferring segments digits, rules of inference. And it turned out we didn't even need rule 3 at all, right? So not actually needed. And we also didn't need rule 11. And Rust helped me figure that out, right? It said, you never used D, so we could skip rule 3, and then by the time we get to rule 10, we have all 10 digits. Okay. I think to make this better, I want to go from B-tree set to some custom data structure, right? You've done a fair amount of C, C++ in your course, so you tend to fall back on Python as your comfort language. Any recommendations on how to learn Rust? Yeah, so you're gonna, if you want to learn Rust, you'll probably want to, hold on, learn Rust. This actually leads to a pretty good site. So this site, I would say you start there, and then you pick whether the best way for you to learn. Book reading, step-by-step, like class kind of thing, or just look at code examples. Any of these 3 ways is pretty good. It just depends on your style of learning. That's how I would say you should start on learning it. And if anything, your C, C++ knowledge will actually get in the way. That's what happened to me, because a lot of the way I write code in C, C++ just doesn't work in Rust, and vice versa. And so that muscle memory in C, C++ is going to get in your way, I think. Yeah, I'm using a Kinesis Advantage. No, Kinesis Freestyle Pro. I moved to a split keyboard, not because I've been programming that long, but I moved to it because Kinesis actually approached me and had me do like a semi-sponsored thing, a stream, where I kind of talked about it. But I kind of like the fact that it's better on my wrists. That's really the big thing. Finding a keyboard that doesn't cause you pain and injury. That's the big motivation. The experience is that with any kind of keyboard change, the more of a difference the keyboard is from the last one, the more difficult it is. And for me, it was a little bit difficult because I moved to a keyboard that doesn't have a dedicated keypad, which I was addicted to, sort of. Like, I went there for my arrows and for my numbers, and so this one doesn't have a dedicated numpad. I actually asked them, hey, could you give me the numpad too? And they're like, oh, try it out without the numpad. Try using the layers for that. And it took me a long time to get used to that. Yeah, John's book and also John's stream and John's YouTube videos are all really good supplemental information. I'd say you're not going to learn from John's YouTube videos or streams, but you'll pick up a lot of like advanced material that will kind of help solidify your knowledge and help test you. You don't want carpal tunnels in your 60s. Yeah, you want to really be good to your hands and your eyes too. Take breaks. I don't take enough breaks with my eyes, actually. So, did I miss anything? Greetings, Cat Peasant. I'm just chatting. This is becoming a just chatting stream. Also, I am trying to kind of clean up my Advent Code days 8 and 9. I ended up using a B tree set for doing the inference to figure out how to figure out the 7-segment display stuff, and it gets kind of ugly like this, and I even have to tell Clippy to not warn me about certain things. So I think to fix this, I really do want to fix this by making my own data structure that does what I want, right? So it's going to need to have something like from a set, take one out based off of some rule and give me the thing that you took out, and I guess we can just mutate and place the original. I want something like that. And then at the end, I think we want one where when we're down to 2, we just want to say, give me the 2, here's the rule to distinguish one from the other. So these are going to be methods that I'm going to have. So I guess I'm going to do this in steps. First, I'll make a structure, but actually have it implemented in terms of B-tree set. And then hopefully it'll clean all this stuff up, and then I'll be able to replace the B-tree set with something better. Something more tailored to what I'm actually needing. So let's do that up here. So we'll make a struct called, what are we going to call it? It's going to be generic, right? No, it's going to be on characters. So it's like a segments. And right now it'll just be implemented in terms of, in fact, I can just do it. Yeah, we'll just put it in here as a member. Oops. It is a chars, B tree set char, right? And then implementation of segments. So hold on. What's first? Replacing where we see B tree set char with that, with segments, and then collect segments. Everywhere where we have where we see B tree set, replace it with segments. Okay, getting there. Collect segments. Cool. And then we got to fix the compiler errors. So it's going to tell me it doesn't know how to collect. We have to implement from iterator for segments. So let's do that. That should be fun, right? implement standard iter from iterator item equals char for segments. Did I get that right? I don't think I got that right. Is it just char? Implement missing members. Okay, that got rid of one error. Okay, we need a length. So let's add a length. Oh, I'll forget to do this if I don't do it now. So the answer here is to just call self chars into. Self. Oh, sorry, it's the other way around. It's self chars is iter into, right? The trait bound convert from is not satisfied. Consider introducing a where. Okay, it's from iter. B tree set char from iter. Is that how it is? I think that's right. Okay, so then we need a length self usize, which is just self chars len. All right, next we need intersection. So let's add the intersection of self and some other, right? Other is another segments. Actually, we can cheat and say self here, and then just say actually intersection for hash set is an iterator, right? It's an actual type called intersection, which implements an iterator where the item is what. I wish it was easier to see this. Item is a reference to the T, but we don't need to have references. We can make this a little bit cleaner right away, right? So we can say self. I could put self there too. Chars. No, sorry, it's not self. What am I thinking of? Implementation. Well, let's make a seg. Can I just say implementation of iterator item equals, and I guess I can use an implied thing there, right? Char. And just say self dot chars dot intersection of other chars. And I probably need to annotate the lifetime here. Did I get that right? Borrow that. Nope. Explicit lifetime required for the type of other. Okay, so I need to give just another lifetime. Do they have to have the same lifetime? I guess so. I forget. I don't know how this is declared. It is same lifetime. Okay. Good enough. So that means I probably don't need that, right? Oh no, I do, because otherwise it'll think that there could be different lifetimes. Do you write Rust at work? A little bit. Implement segfault. Should use an array or something? Yeah, we're going to use a small type because our values are very tightly bound, right? We have 7 segments, we have 10 digits, that's it. But first I'm just having it wrap btree set for us, and then we'll change things. Okay, so equals means I need to implement partial equal. I think we can just get away by deriving the implementation. Derive partial equal. Difference. Difference is like intersection, right? Difference. Yeah, so it's the same thing as intersection. Difference. What's next? Remove. What does remove look like here? I don't actually think I used the bool, so I'm just going to discard that. So we'll just say function remove, mutable self, and it's a character, right? Char. And don't have a return type. Self dot chars dot remove c. Or can I not do that? Expected. Oh, consume it with a semicolon. Ooh. All right. So then I don't need. Well, I guess I'll start with it having the same signature because we don't. It's copyable, so we don't technically need to do that. Okay, we need to iterate it, and we need to be able to clone is easy. Clone is just derive it. But we need to be able to iterate, so we'll do that. Do I need... Yeah, I guess I'll use the lifetime. So it's the same... It's like this. Like that. All right, next. Contains and into iterator is easy too, right? Into iter is just that, but without a lifetime because it just consumes self. So it's just like that. Into iter. Easy peasy. Contains. Contains is kind of like remove, only it doesn't remove. And it returns a bool. Next, collect. Wait, why didn't it like contains? Wait, what? Did I mess this up? Why is group a char there? Oh, probably because it doesn't know what collect is. In order for collect to work, I need to do... Wait. Did I do this wrong? Did I screw something up? Probably pivot a couple times in your career. How do you find the transition a couple of years? How do you find the transition a couple of years or so? I haven't had to actually pivot my career more than once. So I had a job for 20-something years. Then there was like mass layoffs at the company, and so I started streaming on Twitch. I guess you can call that a pivot. That transition was rough because I went from a situation where I was sort of like doing the same thing for so long that I wasn't learning to now being thrown into an environment where I'm doing a ton of learning and meeting new people and stuff. And then the second pivot was when I got my new job, and that's still like there's a huge learning curve when you pick up a job like the one I did. And so and then I have to reconcile the fact that I have to I can't use Rust as much, for example. I can't do a lot of things I was doing, so I'm doing different things, but I am able to leverage a lot of my knowledge on what I had learned before because this programming languages are similar to what I used before. So the hardest part of the transitions are when you go from learning to not learning or vice versa, and when you are just picking up the legacy stuff of the environment that you go into. So you join a team that's been working for 10 years on something, it's going to take you a long time to like collect all of that tribal knowledge. That's the biggest thing. I think with that, as ageism comes into play, not really, not that I've seen. Maybe I've been lucky. If anything, older, more experienced people are quicker to adapt because they can map previous experience, whereas someone who's younger, I think, will struggle a lot because they have no similar experience that they can compare an analog to. But then again, young people have the advantage of being fresh out of school and they're faster minded and there are a lot of things. So it's maybe things that work out to be in a balance. I don't know. Old people definitely use experience to offset the advantages younger people have. Tainted by? True, but they don't have the experiences at all. So I think there's a certain wisdom that comes from experiencing something and then incorporating the things to your advantage. So, but young people have other advantages, right? They're quicker and faster, more motivated. They have more time. I think it all balances out. At least I hope it does. Okay, what's wrong with my collect here? I think I messed up the type somehow. This was a vector. Oh, this wasn't supposed to be a vector of segments. It's supposed to be a vector, I think, of segments. Segment. Good night. Good night. That fixed it, right? They fixed that much of it. This collect, what's wrong with that? Oh, equal is needed because it needs to go into a hash map. So, it needs to be equal. We need to have it hashable. So, sure. It'll work just by deriving it. So I'm going to do that. Equal and hash. Cannot borrow it as mutable. Oh, contains doesn't need to be mutable. Okay, cool. Now we're just down to warnings. What is it saying? I never needed it into iter? Never used? What? Needless collect. Let me make sure I didn't break this. I didn't break it. It passed. Okay. Okay, so I didn't break it, and I didn't need into iter, I guess. But what was that other warning then? How come I didn't run into that before? I have a feeling that this wasn't vector before. But it must have been, right? It was like this one. Oh, hold on. That, right? No? That's weird. Oh, maybe it did have a warning. Because the other one that was similar also had, I guess it did have a warning, I just never suppressed it. Okay, so don't need iter either. We do need iter. So why does it think we don't need iter? Oh, it wants me to not make it generic because, yeah, there's only one lifetime. It's telling me that it can infer the lifetime. So where we need a lifetime, we put the inferred lifetime. There we go. So if I got rid of that, it's going to say, well, what lifetime do you want? Oh, maybe not. Sometimes you need this inferred lifetime. Sometimes you don't. And I still haven't figured out when you do and when you don't need it. Experience trumps knowledge, but only when you know how to use experience. I think sometimes actually experience, you don't even need to know how to use it. I think experience can help guide your intuition. So a lot of the times when I have to fix a bug, it's not that in my previous experience I've solved a bug that is like that. It's more like the bugs I've solved in the past give me some feeling about where to look or what to look for, and that will help speed things up. Given you're iterating over characters, you just have them owned. Yeah, so I just did a minimal mapping, so now I get to tweak this type to make it fit my liking. So one thing I'll do is just remove that, put that in there. We might as well just make these iterate characters directly, right? And to do that, I gotta do copied. Maybe not. Oh, it needs a... Wait, why does it need that static lifetime? Because... Hold on. Probably because copied requires it, right? Wait. Do I need to say that it lives as long as a... Yeah, I knew it was something like that. Because before it was on the item, now it's on the whole overall iterator, right? And when it was on the item, it was sort of implied. Does that mean that when I did the way I had it before, technically you could say that, but it was just unnecessary to say that? Right. So it was unnecessary to say that because it was inferred, but when we remove that, it still needs that, right? As long as I say copied. Or maybe it had to do with what something that copy did. I don't know. All right, so I wanted to do something else here, right? Yeah, I wanted to get rid of that. Copied. And it's going to be the same thing about the lifetime, right? So infer the lifetime for me, please. And then remove, we can just do that. And then we clean this up a little bit. So here's where we get to get rid of a copied. And we can get rid of the dereference, and we can get rid of the ref. See, we're cleaning things up, getting rid of these characters that we didn't want. Right? Get rid of that character. Make sure we didn't break anything. All right, and then what's the next pass? The next pass, probably, I want to start like incorporating some of the stuff I did here. Yeah, this one where I extract one thing and keep the rest. I want to encapsulate this completely. So let's make this a method. What to call it? Like extract. That's what I want to call it. Extract from a mutable self. And then we're going to have some conditions. So that means a type that's a function that can take
Okay, it's actually
a character and return bool. T, and then we get a character out. Put that there. Okay, so then this is just digit 3 unwrap. This is oh, this is different. I have this other type vector of segment. Okay, yeah, then this is not what I want right now. Okay, yeah, I don't want this. Shoot. What do I want? I think I want to make a type to substitute vector segments so that I can use this. Yeah, okay, so then this is a different type actually. Returning reference iterator stuff could not live lifetime, so that lifetime bound, yeah. True, yeah. Struct possible segments. Or segment group? Segment. segments group. I don't like these names. Segments group. So right now it'll be a vector of segments. Implement segments group. Here where that's where I'm going to put this extract. Actually, we'll leave that out for now because the first thing I want to do is find where I use vec and put segment group. Okay, and then fixing up the errors, which we'll have a lot of. So we need a new self group vec new. Easy peasy. What's next? Push. Mutable self segment self dot group dot push segments. Into iter. Here's where we get a little tricky, right? Into iter. Self impl iterator item equals segments. Self dot group dot, well, is this how you do it? Vec segments into iter. Or can I just say self dot group into iter? I guess I can just say that. Okay, and there are two errors here. Oh, right. I don't need that to be generic anymore. Okay, and then collect requires from iterator. Am I doing it wrong by implementing from iterator? Seems like you should implement into. No, but that's right? The from is what you want to implement. Implement it for segments group. And this is segments. Oops. Implement missing members. So this is self groups. This is where I need the other form, right? Vector of segments from iter. Oops. What did I do? Oh, group? Yeah. Okay, cool. So then I didn't break anything, right? Just moving all my types around, not actually changing the logic. Now I want to change some logic. So this mad thing here, this thing is crazy insane. We want to put this into implementation here called extract. And yeah, I shouldn't have deleted it before. I'll just type it again. It was like this, right? Function of character that returns bool. And then ft return segments. I think. Let's see. Oh, no, we return segments, but what does the function take here? It takes a segment group. segments. Mute borrows them, right? No, it doesn't borrow it. It actually owns it. No, but it doesn't need to. It can just borrow it and just tell me whether or not to extract it. Okay, so then, yep. What does it not like about this type? All right, because it's just this. Rename this to group. Or really segments. And then this is going to be self. Actually, this is going to be a problem. I guess we, no, we're borrowing, so this is going to give me trouble, right? If I do self.group, can I move it out? Self.group into iter, all that, collect. I don't think it's going to let me. I'm going to have to think of something more clever. Oh, this should be vec segments. Well, maybe it will work. So it's if f of group, right? Hold on. Yeah. Then do that. Oh, that's segments. Getting my names all confused, so I need to come up with some different names. Okay, here's the bug I was expecting to see. Can it move because it's behind a mutable reference? So I have to think of a different way to do this now. Because the problem is we don't own self. We're just borrowing it mutably, so we can't put it into an iterator. Even if we know that we're going to end up making a new one and storing it back, we can't make a hole in the middle. I guess I can just use remove, right? Doesn't vect have a remove? And just shifts everything up. And we actually, that would have been a better solution before anyway. I just didn't think of it because once we find it, we found it, we can escape. So let's just do that. Remove. Is there a version of remove that does a find? Like a find remove? I guess not. So we'll have to do find first, or just iterate through. Remove takes an index, right? Okay, so we'll just do it the old-fashioned way. For index in 0 to self dot group dot len. If f borrow self dot group index, then self dot, well, this should be something like, yeah, this should just return it. Self dot remove, self dot group dot remove index. Well, return that, right? That gives me a T and panics, which is okay. So then I should panic. This should just do a find though, right? Find. Too many things in vector. Is it on slice? There are too many things called find. You do a for loop over the indices and just make a... That's what I'm doing. For loop over the indices. Or is there a better way to do a for loop over the indices rather than that? Problem is, if I get to the end, what do we do, right? Panic or unreachable or something? Something like that. I mean, that'll work, I guess. It's just, I don't like having unreachables. There's iterator position, which will get you the index. Yeah, I think we're gonna end up changing this anyway. Let's just go with this for now, and then we'll just use this. So it'll clean this up significantly, right? Because then this just becomes let digit 3 equal digits 235 dot extract, and it is group. Actually, it's most of this, so why don't I just copy this? And just take this part, group dot intersection digit 1. Hold on. Did I not change that? I didn't change that yet. I wanted to get rid of the reference to char so I can get rid of the copied. I'll do that in a second. So it's just this, right? And then with the additional thing that let digits 25 equal digits 235. And then I can remove all this junk, right? Let's test this. Yeah, still works. No big deal. Okay, let's fix this intersection thing. This should just be a character plus a copied, and then I get rid of the copied here, and another one down here. Okay, getting better, one step at a time. So we're gonna, now that we have that extracts, it makes it a lot nicer looking, right? It says exactly what we're doing. We're extracting from digits 235 where the intersection with whichever one of these with 1 is 1. Then that is digit 3, and then the side effect is it gets removed, so we can rename it. So I can do the same thing here. Let digit 5 equal digits. Oh, and I want to make a special one for this one, so that I can change this around. But for now, we'll do digits 25 dot extract, and then this lambda slightly smaller. It's just group intersection collect equals EF. And then to make, so here we have to do let digit 2 equal digits 25 dot into iter next unwrap. I think I need to do that, and then I can delete all this stuff. Go away, box. Mutable. Test that. Yeah. So I think I want to make a specialization where we know there's only 2 left. Instead of extract, it's like split. So that I can say, well, let's just take, where is it? Here? Not a specialization. I said the word specialization. I meant to say function. So call it split. Self. And then something segments, 2 segments. That does essentially that, and I want the same kind of thing up here. So f of t. All right, so then this is self, and then what we return is digit 5 and this. Fix the names so that this is first, and this is self, and then this is f. Mutate it until we destroy it, right? Okay, and then we can just call it down here. So let digit 5 digit 2 equal digits 2 5 dot split. Put our function in there. Much better, much easier to read, right? All right. See, it's kind of cool to have these unit tests and make sure you didn't break anything. So it no longer needs to be mutable, which is neat. It's neat when we can make something immutable. Okay, I think, what? This should be put into another kind of split for segments. So we'll make a segment split. Mute self ft char. I need a t. It's this slightly but different. It's char. So it's hold on. Am I always? I'm not always doing a difference, right? There I'm doing a difference. Actually, that's the. I only do this. Oh no, I do it. No, I only do it once, right? EF. No, I do it again here. But like, I'm thinking, how we split should be a function. Oh wait, that it could just call that function. It could just say, give me the, just break it in, give me the character that is left when you remove this one character. Yeah, okay. Hey Endurin, I am still alive, yes. I'm cleaning up my day 8 solution. Sorry that I can't start during EU friendly times. So yeah, this is not a function anymore. It's to take a character and actually it's not split, is it? It's we'll do, actually take that back. This part I'll have to leave the way it is. But it's this part that I'm really wanting to split out, right? Yeah, so it's self.remove, and this is just returning a character. Self-remove C, and then it's just self.chars.iter next unwrap. There we go. Did I not do that right? I guess copied. No, dereference. There we go. So then this down here becomes let f equal ef dot, I call it split, but I don't want to call it split. It's just that. Let's rename it. Remainder? I can't think of a better name. We'll call it remainder for now. Let's put it in alphabetical order. It's when you know you have two things left, and it's like, I get one character, and then that's the other character. Doesn't need to be mutable. See, we know we're accomplishing our goal when we're getting rid of mute. So this is the same thing, right? So we can say let a equal ab dot remainder b. Then we can get rid of this mute. Make sure I didn't break anything. Yay. Still works. Oh, you're happy to have found my stream? Oh, glad you're here. You're off. Thanks for watching. Please don't say mutable or borrow. Bad memories. I'm sorry, Endurant. I wish I was there to have given you some advice. Hey, look, we don't need to have an iterator implementation anymore because it's now baked in. So, Endurant, does something like this scare you then? Where I have like a generic method that takes in two borrows and gives you an iterator that has the lifetime of the borrowed characters, or the borrowed borrowed values. The tick, that signifies, in this position, it signifies a lifetime. So it says that for some lifetime A, this method takes two borrows that live no longer than A and gives you back an iterator that cannot live longer than A. So it's basically it's a bound. It's a limit. It says that when you pass in these two references, they don't need to live longer than, neither one needs to live longer than the other. And then in this position it says this iterator cannot be allowed to live longer than these borrowed references, because it's being baked, it's being put into them basically, right? This one self is being this self reference is being turned into this this other iterator, which has the lifetime of the original self reference. So when it gets really crazy with lifetimes is when references get baked into other things, which is what's happening with this difference function. This difference function takes a reference and embeds it into an iterator. And so that iterator itself has to have the same lifetime. It can't live longer than the reference it has, because it's not legal for something to exist and have a reference to something that no longer exists. That's like the condition that has to be avoided at all costs. That means that you have a pointer to something that no longer is valid. That's not allowed. But I'm going to have a hard time explaining that in a lesson, because it's very difficult to visualize. And also, where even though it looks like the same tick A or single quote A, its position and what it means in each position can be totally different. So sometimes it means cannot live longer than, other times it means lives at least as long as, and yet other times it'll say, like, if you can have, like, when it gets really crazy is when you do something like that and you say like where A outlives B. That means that the self has to live at least as long as this other, and basically other cannot outlive self, right? That's where you have to have these, where you have bounds on lifetimes related to each other. That's where it gets really, really crazy. Fortunately here, we only have one lifetime to deal with, and it has two purposes. It's basically saying the self and the other have the same lifetime, and a lifetime gets kind of absorbed into this iterator. In other words, the iterator can't live longer than the references that you started with. So it's somewhat easier to explain, even though I know I'm not explaining it well enough. It's better than it could be. Yeah, exactly. Not like this. It's a perfect emote to respond with. I understand. But look how look how clean this looks compared to an hour ago. And this all this crap is now just let digit 0 equal digits 69 or 069 dot extract. And then no, it's not extract. What is it? It is extract. And then it's why is it going to that function? Oh no, it is. This tooltip though is wrong. No, it's right. What was it showing me then that looked wrong? It's that. fchar is not right. The actual type is f is a t, where t is a function that takes a borrowed segments until it gives you a bool. That is my part of my old lambda here. It's just that we need to do not contains f, right? And then let digits 69 equal digits 069. Drop that. And test this to make sure I didn't break it. Cool. All right. So, Endurin, did you get day 8 done? With cough, Raimu. Endurin, did you mean Raimu? Yeah, that's exactly what Sarian meant. When you see, like, on a lifetime constraint like that, like going back to this example, this took me forever to learn correctly. And even then, sometimes I think I got it wrong. When you see something like where A colon B, that you should read it as, in general, you should read it as A outlives B. Another way to read it is that B cannot outlive A. It depends on the position you put it in, but it's like placing a bound relationship between the two so that it can't, the roles can't be reversed. That one is always going to be a superset of the other, or, you know, seeing it the other way around, one is always a proper subset of the other. You're on day 5. Well, you shouldn't be watching then. This is spoilers for day 8. Okay, this one was let digit 9 equal digits 69 dot split, and then this function here goes there, and just group contains A. And it's, how did I use split before? Do I just redefine it? No, I put it into a tuple, right? Digit 9, digit 6. Like that. So much cleaner than all that stuff, right? We still have that ugliness right now, but we've buttoned it up, packaged it up somewhere out of the way, and our code still works. We can make that into a method even, right? What is this type? I don't know. Hold on. Where is the top of this? Oh, it's digits. It's a hash map. Let's leave it where it is. It's actually looking not bad, right? So there's a little bit of gross stuff. Where was it? This stuff is a little gross. This stuff is a little gross. I might just like say that this is good enough though, and keep the B tree set in there. The to go all the way would be to make our own set rather than using B tree set. So we would have to implement contains, difference, intersection, length, remove, I guess we can do that. Well, let's get a time on this. So let me make sure I still get the same answers on the real code, right? Going back to day 8, what were my answers? They were 543 and 994266. Okay, so then cargo bench 81. See if this is any better than last time. Benchmarking. Ooh, 197,000 iterations. That's what I want to see. No performance change. Okay. So it wasn't the crazy stuff I was doing. It's really probably bounded by the B-tree set type. So, okay, that improved. We're down 56% on part 2. Oh, right. Part 1 we didn't change. Part 2 we did change, right? So we improved. We're down 50%. Okay, see, Ender, and I'll still be up a little bit later. Oh, you hear split and contains and methods like that, but those can be in any implementation. Yes, in fact, I invented these. Okay, so I forget what Sarian said that they got, but I don't think it was much better than. It's right under 1 millisecond, which is pretty good, right? But let me see if I can get better by removing this set. Oh, you got sub 100? So I have an order of magnitude. So I hope to gain that with my own set. So yeah, here's where we get rid of B-tree set. So we know that the characters are really just A through G, right? There's only 7 of them. So what if we just say characters is 7 bools? Okay, and then I guess we'll keep the outer interface for now. So let's make a function select char usize, and this just says char as u32 minus a as u32, whole thing as usize. We need to, I can't use the type name here, C. There we go. And then, actually I'm gonna call it index, so it goes there. Then I can say, chars self index C. Difference. Don't we just want to... Okay, we're going to have to make our own iterator type. But we just want to make an iterator that checks every one of the other characters to see if we have it. No. We checked all of ours, and if it's not in theirs, we return it. Right? So then let's make a type. Struct segments difference A, and we use the same constraint they have where it's the same lifetime. That's the easiest, right? We can say hours segments capitalized, right? Yeah. Theirs. And then I need to have like an index, so index usize. All right, so then implement iterator for segments difference. And missing members, please. The item is they expected a character back, right? So we'll have to convert back. So we can do that. So then next we'll say if self.index is greater than 6, none. Else, actually then I can just turn this around. Self.index less than 7, then less than 7, so we want to have a side effect of incrementing index. But before that, we want to figure out if our self.hours dot actually I can just should I go to reach in straight chars self index and not self theirs chars self index so let emit equal that. If emit, well, emit then self index. Oh, hold on. It's gonna be I'll turn this around. Let index equal self index, because then I need to increment before I do that, right? So if then would take what? Oh, it produces a t. So it's just that. No semicolon, I think. Not quite. Oh, I need to convert it into a character. Oh, shoot. So yeah, if it's and then, isn't it? Then some. Hold on, doesn't then produces a T? Lazy booled option. Yeah, is there one that just does F, not some F? I always forget this part. You're back. Welcome back. Would these operations be easier as bitwise operations in a char type instead of a bool array? Well, it's that we have sets of characters like these. So, but the characters are always A through G. So, in other words, like the first 7 characters. So I'm modeling it now as, instead of a set of chars, actually just an array of booleans, whether or not that letter's in the set. That's how I'm thinking of changing the design to make it simple, since we know that there's a very tight bound. We should be able to fit it in a byte, right? Not have, you know, a tree of bytes. Anyway, I want a version of, like, maybe it'll be on the cheat sheet, something that, I forget if the cheat sheet has stuff for bools. I don't know if it does. Maybe not. No. Well, okay, we won't try to be smart about it. We'll just say if self index is greater than 6, none. Else if, well, else let index equals that, increment it if, I have to use index here, then some index, else none. That's what I had originally. I just don't know if I could have made it smarter. Okay, this should be index, we need to add it to A, so Is there a better way to do it other than A as U32 plus index as U32 as char? Really? And because you can't convert that to 8, can you? Oh, you can? I didn't know you could do that. I thought it had to be as 32. Well, that makes it easier. So then I don't need that. I still need to do that because if I don't, it'll complain, right? Yeah, complains about the types not matching. Do BA. Oh, I forgot I could do that. But I still need this part, right? Why does it want to... Okay, never mind. I still need to do that, right? Yeah. Yeah, I always forget this binary character, binary slice. I don't know why. Okay, so yeah, anyway, this is how I was going to do it, but then, like, if there's a way to make this into a then, the problem is that then doesn't return an option, so we can still return none, and I'm not sure how to do that with a then on a Boolean. So I'll just leave it like that. So then we have to fix some things, obviously. That was difference, so... This is actually where a lot of things can break. This should say segments difference, ours self, theirs other, index 0. All right, yeah, the problem is I can't just test these one at a time. I have to do them all. So intersection is going to be the similar thing. Oh, intersection is where they both are in common, right? This might go a little faster now that I can just copy this and change it, right? So this is segments intersection. And so the intersection is where they're both true, right? That's the only difference. I think that's right. Someone will tell me if I'm wrong, I'm sure. Or they won't, and they'll just chuckle and say, well, Reimer will figure it out in a minute that he's wrong. Intersection, and then remove that. Okay. Remainder. Right, well, let's do remove first. So remove is just self dot chars self index C equals false. I always feel like I should put a semicolon there, but Musen's like has gotten me thinking I don't need a semicolon there because this whole expression has a type of unit and so does the function, so they match. But that just feels weird, so I'm going to put that there. Okay, so we can't do that. Really, we just want to find the first bit, right? So it's self.chars. Can I do a find? Oh, iter find bit where bit. Why is it a double borrow here? Oh, probably because find... Yeah, this could be an into iter. Now it's only a single borrow. Unwrap. And now the type is different because it just needs to go to char. Oh, shoot. It can't be a bool. I need to find map, right? Oh, this is more complicated. It's into iter enumerate, find map, and then it's index bit. And bit is bool, so if bit, well, bit dot then b a plus index as u8 and then as char. One more parentheses. Good night. Oh, hold on. I gotta pause. Just for a second. I need to figure out where the buttons are. Hold on. I'm back. One of the kids wanted to say goodnight, and they didn't want to be on camera. What's the difference between iter and into iter? Think of into iter as consuming because it takes the self without borrowing. So it becomes the iter. It's like you transform it into an iterator. Its original form goes away. Iter, though, will borrow it in order to return an iterator that's allowed to borrow the elements. So you basically use into iter when you don't need the original. So right here, the remainder is meant to just give us the remaining character. So we're going to consume self and its characters. That the advantage of it is that we're actually owning the original things from ourself, and so we're not borrowing, so we don't have to have these references anymore. So it's simpler, but the downside is that it consumes the original. Yeah, technically it's what Sarian said. I just think of it as it's iter borrows into iter consumes the original. I'm wondering why it didn't indent that. It's going off the end of the... Oh, because of the inlay hints. That's why. Okay, we have one more, which is this. Oh, this is easy. This is just... I need to call next 7 times, really. Right? No. Where is this used? Let's comment it out and see. Where do I use that? Oh yeah, when we originally collect it. Okay, then I know what I'll do. So we'll let mute segments equals self, where the chars is just false 7 times. And then we're going to end up returning segments. And then, whoops. We're going to say while let some char equal iter, right? Into. Segments, so segments chars self index c equals true. C is a T. Oh, we're just iterating, right? There we go. It doesn't know how, is it into iter? Is that how? Yep, that's what it is. What? Do I need to iter it again? I forget how to do this. Oh, it's dot next. What am I thinking? So let iter equals iter into iter, right? We have to do that because it's we don't have an iterator. We have something that can be turned into an iterator, and then we iterate by calling next. No? Oh, it needs to be mutable when we do that. Oh, sure. 4C in. Oh yeah. I'm really happy that the compiler tells me and Clippy tells me how to do it properly. Good morning, Endurn. I mean Imperry, sorry. Endurn, Imperry. I just committed a serious faux pas, didn't I, by switching the two of you. To report the bullying, press Alt F4 to resolve the issue. Okay, now it's time to see if I broke it or not. It's a high chance that I broke it. Yep, I broke it. 297. So I broke it in probably one of my implementations, right? Oh, but it was early on, so we could probably figure this out. Digit 1 is some... Okay. So we broke it early on in either the length... Actually, it's probably length. Yeah, this is wrong. So we have to count the number of trues we have. So it would be chars, iter, filter, c, c, count. Does that have to be double in direction? Why do I have double indirection there? Is that because I can't make this an into iter because that'll consume chars. I guess there's no way to avoid it. I have to double indirection there. Yeah. Anyway, that's probably it. One can hope. No, it's still broken. Unreachable. Oh no. We got to the unreachable we didn't think we could reach. Okay, that's bad. That means we got to a place where we couldn't find the group to extract at some point. Oh, I can? It didn't like it, though. It didn't want me to turn it into... Oh, it did. You're right. That is because... into iterator is implemented for something that's copyable? Huh. Okay. But still, I broke it somehow. I'm sad. Most likely, it is in where we did the intersection or difference. So I need to figure this out. So intersection is where where it's in both sets, right? So if it's in both sets, we return that. There are 7 segments, 0 through 6, right? So this will be 0, 1, 2, 3, 4, 5, 6, and then none. Oh, wait a minute. We don't want to return none. This is wrong. It's got a loop. None means end of iteration. So I have to say how to do this. Loop, I guess. Yeah. We only want to return none if we get to the end. So then it's oh, hold on, it's while, right? While it's less than 7. And then the none goes out here. And this is a return early, right? While it's less than 7, if we find when we return it, yeah, I think this is correct. So I just didn't do it right before, and I have to do the same thing here. This should be while less than 7, if, then return, and then none goes there. Okay. Hey, look at that. Let's see how much faster it is. I'm hoping it's faster. Maybe silly if that was all for naught? Please, please, please be faster. Ooh, 20,000. I think it's a little bit faster. That intersection is wrong? I did see it. Oh, 66% faster. Now we're down to 320 microseconds. So at this point, I always say to myself, Sarian, how much does the parsing cost? Maybe the parsing itself is taking the most time. Oh, the other thing we can do is get rid of, I don't know if this is causing a performance hit, constantly converting to and from characters. We don't technically need to do that, right? I could just put them into indexes directly when we map here, and I think I'm going to do that because it's easier, so I can get rid of all the chars. So what if we reorder this to be indices? It would be index usize, and then I can just say index, right? And then we don't need this index type anymore. And then I don't need to do this addition. I can just say index. Usize. And then remove takes usize. Actually, let's call this index. This becomes an index as well. Just put the index in there. Do you know the code for matrix? Yes, I know the code for matrix. How are you doing, Golden Charizard? Did you solve day 9? Yes, I did. I did okay in day 9, actually. Leaderboard, personal stats. Yeah, I got within. My goal is rank 2 to 3,000. I probably got a really horrible rank for day 8. It says over 24 hours because I didn't start until like 23 hours after it. But even so, I probably would have still gotten a really horrible rank because I struggled on day 8, just like I struggled on day 7. But in fact, I would imagine I would get the same kind of rank around, almost 20,000 rank because I struggled. Yeah, day 9 was pretty fun. All right, now that these take indices, all right, so this can just be C, I guess, and then this becomes index. And then what else? Oh, this is usize. What did I do wrong? Oh, right here, usize. Time for day part 2 was 154.41. You've got rank 57.28. Better than I did. Oh, you mean it was a slow day for everyone? There's also a drop-off, pretty steep drop-off of how many people actually compete. We can actually look at that on leaderboard, or stats. We can look at that on stats. So see the drop-off of the number of people actually have completed it day to day? It's pretty steep. A lot of people try out day 1 and we have they don't come back for whatever reason, right? Maybe they'll come back and do it later, but I guess I should try my rank. Actually, there's a good question. Do the people who don't come back and do it, are they the ones who ranked low? And so is the competition getting fiercer the day after day? Or is it that it's random? Or is it that the people who did it really fast say, okay, this is too easy, I'm not going to come back, and now there's less competition? I don't know. The reason is time. To be honest, you tried day 1, but then never did anything. Yeah, and it could be that actually, a better thing would be to look at a different year, right? And see how many people actually did every day. There's still a pretty steep drop-off. But then you have some core people who wanted to finish at the end, which makes sense, right? Well, what about like a really old year, like 2018? Yeah, actually pretty steep. But then you have a core number of people who stuck to it to the end. Looks like a bell curve. Yeah, anyway, it's fascinating to me. Yeah. Okay, I'm still working on cleaning this up. So, yeah, getting the characters, now we want to do a map here, right? We want to map this into, wait, what? Oh, it's still with, hold on, undo this. Oh. Yeah, there's an interior one. So wouldn't I just want to do a flat map? No, I want segments and then collect those. Or iterate those. Yeah, okay, never mind. I'm just talking to myself. Don't mind me. This is mapping a character to C as a U8 plus binary, or minus binary A. And then actually that's all as a U size. There we go. Okay, and then down here, why can I not collect this? Because they're characters. How are they characters? Who says they need to be characters? Is it segments? No. Okay, somewhere I have care. Where is it? Oh, it's down here. Is that what it is? Anyway, that should be changed too, right? So this needs to be added after the care is down there. Oh, this still says care. Fixed it. And this needs to be fixed as well, probably. There. Yeah, I didn't get to this one yet. So this is just sum index. You do the same thing for difference too. Simplifies it not to hold on to actual characters. Okay, now it's compiling again. Run it. Didn't break it. Let's see how much better perform. Probably, I'm gonna guess hardly any performance gain. That it probably is just making it look nicer. You finish work at 5, 6, then you either play some games, go with friends, just chill. Usually after 8 hours, because you don't want to see. That's true. I can understand that, Neochromer. I use it as a way to stream and interact with you guys. If I wasn't streaming this, I don't know if I would do it. Maybe just to compare notes to like people at work who are also doing it. And like if it took hours, I might just say, I'd rather play a game. No change in performance. Okay, so my bottleneck is somewhere else. It could just be this this list of inferences, and just Sarian picked a better set of inferences. Or it could be the parsing. I don't know. I don't know. I don't think I'm going to chip away at it anymore, though. I think maybe we'll call day 8 done. I'll just be happy with this. We're not using. Oh, that's right. We don't need beat tree set anymore. This is as good as I can make it. Let's move on. Let me clean up day 9, because this had some improvement places we can improve it, right? How do you like Rust? I love it. It gives me an adequate challenge. And you're a web dev thinking of transitioning to Rust since the last year. So web dev as in front end? I don't know if it's the best for front end. It's pretty new to the web stuff, like with WebAssembly. But if you're talking about back end web dev stuff, then yeah, I think it's great. And C++, good language too. I like the fact that in Rust, when I get a program compiled, it has a better chance of actually working. The compiler actually helps me catch a lot of things. Bit confusing the code you write, but assume this is due. No, there's probably the way I wrote it too is also just not as good. Rust doesn't help you completely, like it doesn't. Rust could do more to help encourage you to write better readable code, but that is a pretty tough challenge, right? The biggest things that I do wrong are I don't break stuff up into functions, so I end up with these massive functions. Now Rust will start to complain at 100 lines saying that my functions are too complex, which is nice, but even at 100 lines it can be kind of hard to understand. Right, this is the flood fill stuff. This is the flood fill algorithm exactly. I was wondering if I did something silly here that I could improve on. Like, when I insert something into the border, can I just immediately insert it into the visited? I'm going to end up adding it there anyway. Nothing comes to mind, but it also might be just because I'm tired. How about down here? Can I improve anything here? Can't think of anything. Maybe when my brain is refreshed, I'll think of something. But I think, yeah, I don't see anything. I think I'm just going to check it in and rate somebody. Or maybe just talking for a while, because I probably didn't cover all his chat. I wish I had something that looked nicer in Rust. What if I look at a previous day? Yeah, that wasn't good. Actually, the early days look a lot nicer. Like I have this one where it's just a chain of function calls. When you can get code that's just a chain of function calls, it looks like an assembly line, and I think it looks beautiful because I envision this as like literally an assembly line, and my input is coming in, we cut it into lines, and then we trim the white space off of each line, and then we convert each line into a number, and then we put those numbers into a vector, and then we do a windowing function over that vector, and then we add up those triples, store those in the vector, apply another windowing function. We look at where we have increases, we count those, and that's the answer. Is that idiomatic, Rust? I don't know. I mean, it's one way to do it. It's more functional. There are fewer semicolons. Rust is general purpose enough that there are multiple ways you could write this. I could write it imperatively, have intermediate variables, and it might read better for someone used to a different style. So I don't think that I know enough to say whether this is the idiomatic way or not. Is this another Enduran versus NParry fight? How does your day 4 look? Day 4, oh, the bingo one. Yeah, I ended up breaking this one into parts. So there's the parsing part, and let me get refamiliarized with this. Yeah, so there were two parts to the input, so I decided we get the first part and then we get the second part. I kind of like the way that I got the iterator of lines, and then I called next to chop off the first line and turn it into the draws, and then just use the rest of the iterator to form the boards. I like that. And then we can close this. I use fold, but I'm not sure I like fold because I think it's hard to read, especially with the inlay hints. It kind of scrolls off the end and you can't even see the end of the line. And the types are complex. It's almost better not to have, not to use fold because of its complexity, because fold takes an initial value and then there's a function, and the function takes that initial value and then the item that you get from the iterator, and you're supposed to produce the what they call the accumulator. The accumulator that comes in being initialized here, it goes back out and then comes back in on the second call. And just the complexity of where things go, that you have to know that that's the initializer, that's the accumulator in, that's the accumulator out, and that you have to have this function at all as an argument to fold. I just don't like the complexity of it. And I don't like that I had to do this panic there. I think a more elegant way would be to find it where there always has to be an answer as long as the input is valid. But this is like where, what was it? What was the reason why we did this? Oh, this is if draws is empty, or if there is no if there's no winner at the end of all the draws, or if you haven't consumed all the boards, right? Then it's possible to fall out and say that there's no winner. I think here is a similar thing where you keep playing, you never find a board that wins. It's like, well, I don't know, I guess the input was bad because we didn't have a winner. Should I do previous day's AOC in Musen style? Yeah, Musen style is what I had for day 2. Or was it day 1? Day 1, part 2, right? Where you don't have any semicolons. Now, I did a little bit more in that I have a comment for each line, but Musen would just have done this, right? And you just see just a hopefully vertical list of functions, but then when it gets more complex, it goes really far indented. Feels like my answer is way shorter compared to yours. Oh, for day 4? Well, it is broken up into different pieces. So there's the parsing part, and then there's the playing part, and then the play is its own function. We didn't go into that. So for play, it was this is where you see if the number you drew is actually on the board, and then this is where you see if there are any rows or columns or diagonals, I think, even, and that's its own function, right? Was it just rows and columns and not diagonals? I think so. Yeah, because that's the row check, the row count, that's the row counter, and that's the column counter. If either row or column gets bingo, then you win. Yeah, just rows and columns. So maybe it looks smaller because I broke it up into several functions. Go by line count. Is yours more than 200 lines? Then yours is longer than mine. But mine fits in 200 lines. Why is make row down here? It doesn't go there. I'm tempted to move it. It goes with my other functions. I don't know why why it ended up way down at the bottom. I don't know. So I'm getting tired though. Let's see. Anybody else still up doing stuff? No, not really. Can you put the possible bingo options into an array of vectors? Huh. Okay. Could have done it with the for loop, but what is the fun? I know, what's the fun in that? Just pick a different way. It's so late, I don't think I have anyone to raid, so maybe we'll just end it. End the stream. But yeah, if you're just joining, I'm sorry, but I'm on the way out. We did Advent of Code today. I'll be doing it again on Friday. Maybe Thursday late. Depends on how I feel about it. But either way, I'll be back to do the next couple days very soon. So thank you for watching. And take care, everybody. Have a good day and good night. Bye.